Hello, everyone.
Hey, Andres.
Hi, Andres.
Hey. So, it's 1 p.m. Eastern. I will give people another 5 minutes or so, to see who's showing up. It's kind of hard to get started without the right folks on the call, unless you guys want to, we can because the way that it's structured, I just want to let you guys know, and maybe let me get going here with the initial starting point, which is actually, come on, load. Slow.
Looks like there's a lot of people in the ZK session.
Yes. Yeah, which is fine. They want that. Let me we're going to talk about that, but that ZK is not relevant to here. My sense is, I doubt that they're talking about Plonk and things like that. Let me just do this, share this, and then can you guys see my screen?
Yep.
Very good. Let's make this a little smaller. So this is going to be the starting point. Right, so this is really the 4 layers, the way that I see them. Again, this is just starting so high level, and then the way that this is designed is to work through these 4 layers with regard to those 3 key questions, right? And some of these key questions might not be relevant to those layers, in which case we can simplify things, but for completeness sake, that's where it starts. So interface application layer, where you have sort of custom interfaces and API gateway and application logic, and then below that you have a middleware where you have workflows, identity, accounts, workgroups, messaging, and then the actual processing layer, we have a transaction pool, a virtual state machine, and storage. And then, so that's your typical thing for, you would have for like a loop ring or
it's layer 2 basically. I mean,
that's layer 2, yes.
Yeah, and then below that's layer 1.
And below is layer 1, exactly. Right, so nothing outrageous, but I think that it helps ground the discussion. We have Nick, who just joined us. Currently, there's no one. I mean, not no one, Nick, but it's like we're still giving people a little bit of time to join. Actually, let me jump over to the chat here and let everybody know that we are.
That makes sense. The client blockchain client improvement session is running a little bit on the long side. You may have folks that are in that are going to be joining you. The phone book is kicking off at the same time, and Zero Knowledge Circuits is also going into its second hour. So you might have some overlap there.
Yeah, which is totally fine. We can extend. We can start later. I'm just gonna hang out here until we can chat a little bit on general terms. But I'm not really gonna get the work started until we have the set of the right people here. Right.
Question while we're waiting. So John has brought up batching a few times, and I don't really know much about the concept, but I think it's something that Karthik was working on as an alternative scaling solution. Are batching and sort of traditional, or I don't know, traditional maybe not the right word, but the standard layer 2 solutions mutually exclusive, or could batching be?
No. This is part of layer 2. Batching just means that's what optimistic, that it's a roll up, right? A batch is a roll up.
Okay. But so Could baselines, whatever Karthik had in mind for baseline, be implemented on top of layer 2, so you can have scalability multiplied by batching? Or does that not make sense?
No.
Okay.
So the batching just means you have 1,000 transactions, and then you need to combine them somehow into one on-chain transaction.
Yeah.
Right, and that's the challenge here, because you want to bring down the transaction cost. So if you have 1,000 off-chain transactions, baseline transactions going into one on-chain transactions, obviously that on-chain transaction is $5. Your transaction cost drops significantly, and that's what you want to do. What you need to be mindful of is that you actually, and that's one of the key questions, is parallelism versus determinism, right? So if I have 10 transactions that are dealing with the same document, right? And as it changes hands,
well, they have to be done in the correct sequence. Yeah,
they have to be done in the correct sequence. So if you have an MSA and you're kicking 10 orders off, and then you actually need to be mindful of the ordering, because of the sequence of the ordering, because different pricing might apply, right?
Okay.
So that is going to be handled the same way that Ethereum handles that, through nonces.
Okay.
So you're and it's going to be first come first serve.
So
right?
all of the transactions between a given set of entities have to be done in a specific sequence, but can transaction entity pairs be parallelized? So like company A.
So if A and B and A and C, then those transactions that are independent. So think of them as like processing channels. They're a workflow. So you can operate. You can run multiple independent business processes in parallel. So that's the advantage. So that's why, and there's a design choice that we need to think around. That is like, when you have a business process, it is probably worth to have that as its own account, that has multiple owners, which are part of the work group, because then I can manage the sequence in that account through nonces, and then I just evolve the state.
Okay.
Does that make sense?
I think so.
Right. So it's like I put in the MSA, nonce equals 1, right? And then I create the first PO, nonce equals 2, and then I create an invoice for that PO, nonce equals 3, right? Well, if I have then I have 2 POs, right? And then the question is, which comes first, right? And if they're cut from 2 different departments against the same MSA, right, then it's whoever comes in first, right? And then becomes a question, what are we going to use as a sequencing mechanism? Typically in Ethereum, right, you would use the transaction fee, right? The one who pays you more gets right. We don't have that here. So we need to talk about, are we going to use the timestamp? Is that the right timestamp? Is it are we right? So are we forcing everything through one identity, right? That needs to, so are you resolving the sequencing on the submitter side, and they just need to submit it drip by drip and say, this is I have, this is nonce 3, this is nonce 4, this is nonce 5,
right,
when I submit it, right? So I need to maintain my account on as in a wallet, right? That needs to take care of that. Or do I just, am I not making that, creating that complexity, but just simply dumping it on the client, on the baseline stack, to use something like a timestamp or a CRDT, to create that sequence. right? So those are the kind of like, you know, decisions we need to talk about when we talk about parallelism versus determinism. But you know, anything that is not logically causally connected, you can run in parallel. So if you have 1,000 companies, right, that work with, you know, then they can all run, you know, 1,000 transactions in parallel without having any issue.
Yeah.
Right.
Okay. Cool.
Right. So it's only within one workflow, within one business process that's being repeated, that you need to worry about determinism.
Okay, that's good. Yeah,
does that make sense?
Yeah,
so,
and that's really helpful, because if everything had to be done in like one thread, it would be impossible. So yeah, that's important.
Right. So that's, I mean, again, a nonce is a possible solution, but it's a simple solution and it has been used before. Right. So let's not get fancy. Now, there is one caveat to that, right? And the caveat is, if you have what if you have set up, and this is sort of like, this is now you need to talk about the tech scenarios. What if you have set up, if you have to set up the same thing, right, with the same company, right, the same MSA, right, but on two different baseline clients, because and that's something that we need to think through. What if, let's say, Coca-Cola and FedEx, right, had or I don't know, Amazon and FedEx, or U.S. government and FedEx have set up a contract in MSA, right, and that is used by different departments. And these different departments use different implementations of a baseline stack, because, I don't know, the DoD doesn't like Provide and rather would go with Microsoft. And the Commerce Department doesn't like Microsoft and rather go with Provide.
Okay, but they're different clients, but they're connecting to the same network, right?
That is the question. If you're using the same MSA, right? And are there logical connections, right, in the MSA that constrain the sequencing on two independent baseline implementations? That's the problem. If we need to solve for that, then we need to synchronize. We need to synchronize. Then we need to synchronize a baseline network, and that is, then you're de facto creating a synchronized overlay network, and then you're creating de facto a kind of blockchain over another blockchain, right? Then baseline becomes a side chain, right? And then you have a problem again. How do you come to consensus, right? Then you need a consensus mechanism to say, yes, this is really, yeah, there's like, even though the DoD sent that thing in, it's not, and the Commerce Department sent in that PO against the same MSA, this is the right sequence, right? It's like, and we can, you know, so it becomes really a question. It's really a business question. Do you have these scenarios, or not? If yes, then you need an implementation of baseline that is actually a network, right? And if not, then you can use a baseline implementation that is a single operator. Does that
single operator for every pair of companies?
No, so to keep with that government FedEx example, right? So if the MSA has no linkage about a specific type of product, right? In terms of then I can implement on Provide, and I can implement on Microsoft, right? Independently of one another. And then the Provide stack and the Microsoft stack for the US government doesn't have to be connected, because the MSA does not provide a coupling between the orders of those two agencies in terms of discounts.
I'm not seeing. So I'm assuming that all of the clients will be compatible. So I'm not.
That's not a given. Right?
Okay.
So compatible in terms of if there's a standard, yes. If there's a standard data model, yes. But the inner workings could be different, and there is currently no requirement that two clients need to be interoperable.
But
okay.
even
if they are,
sorry,
apologies. Even if they are in the in the examples that Andreas you explained, we will still have a problem. Because I will draw the parallel. So if within a big company, there are two entities that use two different CRMs, right? One may use, I don't know, Salesforce, or even the same. One has its own instance of Salesforce, the other has its own Salesforce instance as well. And the data and the way the workflow and processes have been designed might be very different. So what you are saying here is that it's the same company. They may have like one contract, for example, the MSA, that has an impact or that is applicable to both Salesforce instances. However, the inner workings, so even if those stacks, if I go back to baseline, are compatible, like they are interoperable, that's not really the key challenge here, right?
No, the key challenge before we even get to interoperability, the key challenge here does the MSA provide a tight business coupling between orders, for example? So do they create orders from different entities, different departments? Are they logically connected, right? So are they? Yes. Right. So that's the thing. If they are, then you're using different stacks, then these stacks need to be synchronized.
Yes, exactly. Right? So my question is, one of the solutions, or maybe I didn't understand that you are laying down, is that we should explore how to solve that like out of sync issue.
No, we don't. So my point is, because that requires so I think from a pure scaling point of view, that is not a problem that this work stream needs to tackle at the moment. That is a larger discussion of whether baseline clients should have a consensus algorithm between them as to submitted transactions or not. Even if it's just about consistency, right? Whether we require strong consistency of the transactions, of the submitted transactions between the different clients, or do we require eventual consistency, right? So that just means that if I've created a certain ordering, if one client has created a certain ordering, that is the correct ordering, right? And if other clients have other orderings, they need to follow that ordering.
Yeah. So to go back to the
that's
initial
strong
point,
consistency.
Yeah, about scaling. So if I'm part of a role group with two different workflows addressing two different business processes, within workflow I have a series of work steps that are interdependent. However, we are saying that if I commit to or if I baseline every document part of the process, MSA, PO, invoice, etc., is there a way from a scalability point of view to batch, all of those steps together? So from a business point of view, I reduce the cost of the overall, workflow execution, right? Is it one of the, okay.
Yes. You can, and that's where the concept of like an ordering parameter, or a nonce, as it's often called, comes in.
Yes.
Right. So and then it's just a question, who manages that? Is it the submitter who needs to manage the nonces, and then the client tells you that ordering is correct based on what I have, or no, that ordering is not correct? right? So you can have you know, you can have conflicts in terms of like the nuns. So that's one area where that's why it's important that that the clients order transactions, because in contrast to Ethereum, there is no transaction fee associated directly with the transaction, and everybody, it's a free-for-all. It's like, no, here's a user, here's an entity that submits 1 or 2 or 3 or 4 transactions in a particular sequence, and the client just needs to ensure that that sequence aligns with what it has in terms of a sequence, so that
Yes.
the first transaction that was submitted is the current nuns plus 1, right?
Okay, but there is an assumption here that the system of record time zone or time settings is aligned with the client, the baseline client, if you want to call it that way.
The client is the source, is the golden source.
The
baseline client, is that. So the
question
has to be.
So if my system of record is SAP, and my record is created, my invoice record is created with a timestamp as per my own system, and everything that is timestamp and like ID sequence of those documents is like follows the logic of the system of record or the business rules, we are saying that this is not the source of truth. Our source of truth will always be the baseline client. Is that?
The baseline client is the source of truth with regard to the sequence.
To the
so
sequencing,
like,
okay.
With the sequencing, right? So an invoice is not finalized until it has been baseline, which means it has been checked that the invoice is consistent with the business rules that have been agreed upon between the two parties. Right?
Yes, that's
so
what
you
makes
might
sense.
you might have generated it, right? So you have a preliminary invoice, or you have an invoice, but you haven't sent it yet, right? To the
counterparty.
To the counterparty, right? That's the key thing, right? So if you haven't sent it yet, right? That's what baselining is. Baseline is, I am checking the integrity of the invoice against the business rules that have been agreed upon between both. So in case someone fat fingered something, you can say, no, that invoice doesn't conform, so you have to go rework, right? Now,
yeah, so if we follow that logic, one moment, it means that the invoice, well, we can only accept the validity of the invoice once it has been verified by the counterparty and the proof of the validation is on Ethereum. Then it is whatever timestamp is returned to the baseline client is basically the timestamp that we should use as proof, right? Not as proof, yeah, misleading, as ultimate confirmation that the cycle or the process or the work step, I should have said, is completed.
Yeah, let's stick with the example of the invoice. So party A creates a proposed invoice. That invoice is then sent to the baseline client and validated against the business rules.
Yep.
Right. That updates the state of the account to be proposed valid invoice. Right? Because you've checked it against the agreed upon business rules, and the invoice conforms to that. Right?
Yes.
Which means it's in alignment with the order that it was cut against, blah blah blah, right? And now you're once that is in, you then send that invoice via EDI, right, to party B, right, attaching the baseline proof. right?
Is there?
Hold
I
on,
know
hold
why.
on, not done, not done, not done.
Sorry.
Party B gets that message with the invoice and the proof. It goes and then checks the proof, right? Is the proof valid, right? Is the baseline proof valid, which it can do. That's a simple validation step. And then it updates the state on baseline of the document as invoice accepted.
Question. Is there a case where it could be designed where party A sends the invoice to party B directly, and party B is the one doing like the validation or doing the verification that the
I don't need
invoice is
baseline.
conform. Sorry?
Then I don't need baseline.
No, this is the baselining. And then when it's done, then the proof is added to the
But
Merkle
there's no
tree.
value. The business value, right, for party B is that it doesn't have to do that validate. It doesn't have to go against its own internal system of record, which might be incorrect, right? It just goes, it can rely on the baseline proof as the proof of integrity that the invoice has passed all business rules.
This is very specific to this use case, but
no, it's general. Any document, any business document.
Yeah, my point was not that they check against their own system. It's that they will deposit in their own system, not check that it's consistent with what they have because they don't have the invoice yet. So they receive the invoice and the serialized record. The check is done. And I'm not saying is that the right thing or not. I'm just asking if there are any circumstances or could there be any advantages to have those steps. So party A sends the record or the invoice, to party B. Party B just deposits the record, confirm, and then if everything is confirmed, the proof is deposited in the shield. For example, in the shield contract, it doesn't have to be. So, and if the answer is yes, is no, sorry, it's okay. I'm just asking the question.
So here, this is let me say here, this is sort of like the sequence. Maybe that's easier, right? So the invoice goes from here to the baseline, right? And then this is okay, then baseline, and the next one is then invoice validated, right? I'm going the happy path here, right?
Yes.
Right, so that's invoice validated, and this goes then to okay.
While you are drawing,
so that's receive. So and the next thing is this is party B is validate invoice, and that goes against here, and then the next thing is, and again, sorry if I'm drawing this. So if this is okay, this is the happy path, right? So if this is the happy path, so this is complete invoice mark invoice, right? And that's here, right? That goes here, right? And then the last one is then here is upload invoice into ERP of party B. Right, and this one informs here's also this is invoice accept the acceptance notification to party A. Does that make sense? So you start here, you propose the invoice, it's baselined, invoice is validated, it goes to party B that validates the invoice against that, right? Then it updates the record here in baseline as accepted, right? So that gets, party A gets notified, and then the stuff gets uploaded into the ERP.
Yes, it
not
makes
before
sense.
then.
It makes sense, and we are not saying like the only step, sorry, that I did not include was the invoice validated the first time. So before party B validates, because I was thinking that if party A sign, party B sign, party B validate, and then the proof is that it's actually both parties have signed and accepted that the invoice is confirmed. Therefore, the invoice is baseline. So I understand perfectly well, and it makes total sense. I was not arguing anything against that sequence. I was just asking if there is any case where the sequence that I have described can be applicable.
No, because then you have no business value, right? The business value is here that you can straight go to processing. There is no validation steps, so all the people that are doing invoice validation right now, that are going through that are things that do a two-way match or a three-way match between order, receipt, and invoice is no longer required, right? That matching is done in baseline, right?
Yes.
So you've externalized the functionality of your ERP into baseline, and you've simplified it, right? The goal in the end is that baseline becomes your ERP.
Yeah. Okay, I'll be careful about this. I don't. Yeah, that was not exactly the point that I was trying to make, but I get your point. I think we can move on.
So becomes your ERP with regard to intercompany commercial transactions.
Yeah, it's all about what are the acceptance criteria and what is the business logic within the circuit.
Right.
So I understand what you said. I think I'm not able to clearly explain, so it's on me what I'm trying to explain. But yeah, that makes sense.
If you can draw that, then that's probably helpful.
I can share.
No, you can draw in here.
Yeah. Yeah. True. I can draw in here. So let me go to the. Hold on. So I need to go.
So the key thing is that process you can run 1,000 times in parallel.
Yes. These are.
Right now, if you have multiple invoices, right, then you need to make sure that they are in the right. If you have multiple invoices between party A and party B, right?
I'm sorry, Andrea. Give me 2 seconds because this is lagging on my side for some reason when I open diagram.net, and I don't want to crash things because the other session starts in 20 minutes. So, I'm in now. So, okay, key invoice use case. Okay, I will start drawing.
Yeah, you can wherever you want to draw.
Invoice propose. I'm just doing below what you did.
And I'm sharing the screen so you can,
Yeah.
so task can see.
Invoice. So this is still going through the baseline stack for like the messaging component of the baseline stack. Then it is received by the baseline stack of the counterparty here. I'll just put it. Oh, this is lagging a lot. Up. So I'll put baseline stack party A. Oh. Is it on? Oh. Party A. Baseline stack party B. I think there is some lag, so apologies for this, but I'm actually typing. So I should have put system of record. So invoice sent. Received. Oh.
So what you're saying is you're just communicating the invoice through the baseline messaging system from
the first step.
From party A to party B.
Yeah, the first step.
Without any validation.
And yes, because for me, the validation and the value of the validation for the subsequent steps is to confirm that both parties, so the business logic of the circuit will be, for example, that we have agreed on a set of key fields that should match. And if we have to link that back to the MSA, so both parties are aware because the MSA would have been baselined already. So I can directly receive the invoice, verify this, and once I'm verified, because both parties would have signed already, it can be then, I will add it.
Okay, so where's that verification happening? Which system does the verification?
Here. It could be, that's what I was asking. I don't know the answer, or if that's the right way to approach it. It would be baseline stack. Sorry, no. I will invoice receive, and no, that would be here. Signed. Why do we have this twice? I'm confused. My bad.
So you're saying you want to send the invoice from A to B, have B sign it and saying, yes, I got it.
Yes, and then this is the stack. I receive the signature, and then this is where the verification happens, and then we can deposit. So this is, based on I send message, I sign, I confirm, I verify, boom, it's confirmed, then it's deposited.
Yeah, but okay. Your verification, and then you're signing it. What if the invoice fails?
So if the invoice fails verification, a message should be sent to both parties, right?
No, I mean, in your scenario, yes. In my scenario, in my scenario, no, right? So in that scenario, only party A needs to know. It needs to rework the you're sending garbage. The key difference is, in your scenario, you can still send garbage over to party B. In my scenario, you know that you will never send garbage over to party B.
Again, if this is very, I think that there could be, I don't know, instances where before verification happened, both parties need to sign the document or the record. In that instance, I agree that one big value added of baselining is to check first before we baseline, before we confirm that there is consistency, that the two systems have the same invoice at the end. So I check against a first set of rule, okay, and then yeah, I mean it makes sense. Don't get me wrong, I totally get it.
Yeah, so I have done a lot of procure to pay,
Mhm.
and like in Ariba and in SAP and Oracle and so forth. And what happens is that you check your invoice that you're generating against your data that you have based on the order you received, based on the receipt that you got, right? And then you match those up, and then you generate the invoice, and then you send that invoice over, so that
Yes.
party A to party B, right? But party A still needs to go and check that invoice against the order and the receipt that it generated to make sure that there was a three-way match, or it could be a two-way match, just the order and the invoice. And then payment is scheduled. So, but that still has, right? So, and then you typically send an acknowledgement. Yes, I got your invoice, right? So that's your kind of quote unquote signature. You don't do a digital signature there. You just send a message back. Yes, I got it, right? You still have no guarantee, because the two systems of records aren't synced, that what you received is not garbage, or not garbage, but does not
Yes, I
align
understand.
with your record, right? So the big advantage is if you send an invoice with a proof of consistency, right? And that proof of consistency is validated, right? You just, and then that the data on the invoice is accurate. The advantage is if you have an issue in your system, right? You send it in and then suddenly it gets flagged, right? You know that the invoice you got is correct, is the source of truth, not your system. And then you can change your system.
Yes, it makes sense.
That's the key. That's the key thing. Right?
Yeah.
And the key value prop is I don't need to do these checks anymore. All the documents back and forth are always, I know what I'll get is valid. I don't need to check it anymore.
Yep, that makes sense.
Right? And I can correct my books and records because some junior analyst fat fingered something in Oracle. It's like fat fingered an address or something like that, or there was a mass address update and it screwed up an address field. I will know that, right? That's the beauty of it, right? It's
yes. I think the way I was thinking for this is already thinking about the next steps. Like if a third party, for example, like invoice factoring company, what type of proof do I want? What do I want to check? What do I want to verify? It works okay for both. Don't get me wrong, but I totally get it. So unfortunately, I need to drop because
I know.
I have to step to the other one. Yeah, but that was helpful already.
Okay, cool.
Okay, thank you. See you on the other side. Breakout 6.
Yes, so to speak.
Yeah, thank you. Thanks. Bye.
Hey, Jörg.
Hi, how are you doing?
I'm good. This is a very intimate setting. We actually really haven't started that. We had sort of like some initial high level discussions around
I followed it on YouTube because I was in Track5.
Yeah, okay. So it was really primarily around how do you keep it's like the right sequencing, so determinism on state changes.
Yeah, I got that off. Yeah,
right.
Yeah,
So
got that off. Yeah.
Right. So
listen, I mute myself again because I'm in a very loud place.
That's fine. No issue. So I think so what I want to do, and we'll just get started. It's like this is now already 45 minutes in.
I have a quick question.
Yeah.
So you mentioned earlier that clients are not necessarily guaranteed to be interoperable. I mean, isn't that going to be kind of a problem if a large company has to run several different baseline clients in order to connect to different customers?
Well, as
Seems
long as
like-
each one is consistent, right? So interoperable means that, for example, you could use different types of proofs, right? So so for example, I don't know, an ENY stack would only support, zero knowledge proofs based on like Graph 16. And a Microsoft stack only, would do like only supports dark proofs or Plonk proofs, right? So they're different, right? So you would have to agree, yeah, you would need to, in order to do that, you have to support all these different schemes, right? So that's at the most basic level. It could even go further and say, can I send messages? So it's like, is the messaging system between two clients connected?
Yeah.
Right.
I mean, I could see why you'd want to have the ability to have different systems, different zero knowledge proofs and different networks. But on the other hand, it seems like part of the beauty of baseline is you only have to connect to one network.
Yeah. So again, I think that's the same question that you have with layer 2 scaling solutions on Ethereum, right? You can have just the one operator model, right? Or you have a model of an overlay network where you have multiple operators that stay synchronized.
Right.
Right.
Yeah.
So and both have their pros and cons. Right.
And I guess so. Theoretically, each client could support a different layer 2, right? I mean, like, you could have the Microsoft could use one layer 2 and Provide could use a different layer 2 for their baseline.
Yes, it really depends on what you're synchronizing on, right? Are you synchronizing on are you doing it like are you synchronizing on a proof of correct execution as Ethereum does? Right? So Ethereum does all the processing, and then that block becomes, or that's the proposed block, and everybody needs to agree on that or not, right? But that all the computations have been done, right? So that is sort of like the hard consensus on state, right? There is a softer consensus of just ordering, right? Is there a consensus on the order of transactions? Because they might be relevant across clients, right? Because of the discussion that we had, right? You Microsoft or the government connecting to two different baseline stacks.
So you can't require that all connections between company A and company B under the same MSA be done with the same clients.
Yeah, because if you have very big companies, right, they have different, they might each business unit, right? There are different business units, right? AT&T has a 5G business units, then it has a voice business unit. They have different IT departments, right? So and they might make different choices.
Wow. Okay, that really complicates things. I mean, could you require them to run multiple clients could it be a requirement that in order to do business between company A and company B, they both have to agree on the same clients, even if that means running multiple clients on each side?
Yeah, so this is where interoperability comes into play, right? It's like, do I want to require that? Which means, I mean, just think about the when you're going, switch sides and put yourself into the role of a CIO and says, it's like, wait a second, I need to run a Provide stack, and I need to run a Microsoft stack, and I need to run an EY stack at the same time. I don't want to do that. It's like EY is not even a vendor of mine. It's like I have to go through all this vending process, and just because FedEx is only using EY, that can't be.
Yeah, I mean, there's a lot of trade-offs. I guess on one hand, that's a big problem, what you just said. So it's better to have them interoperable. On the other hand, if they don't have to be interoperable, you could use different layer 2s and not be stuck on one layer 2 for the rest of time, right?
Well, you again, and then it comes back on what are you synchronizing on?
Yeah.
Right. Are you okay? So are you okay to send a message on a Provide stack over to a Microsoft stack, and then get it get a proof back from a Microsoft stack that goes into the provide stack that shows it to you, even though provide didn't generate the proof, it came from the ENY stack. That's the interoperability, right? So that requires vendor cooperation to define that, and that's, for example, what's being discussed right now in the communications business automation network, where we have pretty much exactly the same situation, where you have different applications from different vendors, and you don't want to have vendor lock-in. You want to be able to switch out different vendors if you want, and you don't want to have to run multiple stacks at the same time. So that's where this requirement for interoperability between different stacks comes in. But we're not discussing that here. I'm just saying this is it is relevant for scaling. If you're talking about how many messages can you handle, and is there a requirement that we need to, and that's less an issue here. I think this is relatively straightforward, but it becomes an issue here, right? On the middleware layer, because it's like on the messaging, once I have done the validation here and I see I don't have that customer in my stack, right? Then how do I find it, right? That's where the phone book comes into play, right?
Okay.
But can I handle 10,000 messages a second if I have 1,000 customers, right? Can I do 10,000 a second? 20,000 a second? Like, which type of messaging system do I need to utilize? So if I, for example, I know Kafka can handle it, or AMPQ, right? It's like they can handle that with the right setup. But do I need to, if I just needed to have that in one stack, that's easy, right? But if I need to replicate messages over to other clients, to other baseline clients, then that becomes more challenging, right? Then you're saying Kafka can do that, right? I can do that, right? AMPQ can also do that, right? It's like, or if you're using, for example, peer-to-peer, it becomes really hard because then you need to flood the messages across the entire network if you don't know all the clients, right? So the question is, do we know the clients, right? So the question is, if we have a phone book of validated identities, do we know all the existing clients? And if the answer is yes, we can have a more centralized approach, a more federated approach on the messaging side in order to reach scale. Then then if we're just looking at a single stack, right? Because I can internally scale, that's easy, right? But if I need to replicate across, and I need to know, oh, the message was consumed, so I know it's like, oh, I can't handle this message. It's like, you need to do that, right? But then who is the you, right? It's like where am I sending it off, right? To which Kafka broker am I sending it? Do I know that? Right, and that's where the IDs are important. The ID documents, where I need to know the service endpoints, etc., etc., etc.
Okay.
Right. So that's where, for example, if I am Coca-Cola, right, and I run provide as part of my endpoints, right, I need to say I run provide. Right. So that if you're looking up, oh, okay, I need to specify in my message that it actually needs to go to provide, because Coca-Cola is operating on provide and I'm running on Microsoft. But then the Microsoft stack knows, oh, okay, Coca-Cola is not here, right? But there's a baseline message for Coca-Cola, but I know where to send it. It has to go to provide, and then you can negotiate. Then you have extended baseline on the messaging layer, but not below.
Oh,
Does
okay.
Does it make sense?
Yeah.
So Jörg, please chime in. I don't want to like, you know, it's like dominate the discussion. So anyway, so I think that's the key question here. So where we have this, we talked about like interfaces application. I think this is for this here transaction scaling. This is we just need to like ensure. So it's like the API gateway needs to scale, right? So, and this is then here also messaging, right? And here we need to say, we need to say, for single operator highly scalable.
Cool.
Okay.
I have to
Okay.
dip out for to take a call. I'll be back in 30 or 40 minutes.
Okay.
Cool. Talk to you later.
I'm just doing the no, I'm not. Jörg, you're still here?
Yes, I am.
So, any thoughts from your side? Ja, wir können es auch auf Deutsch machen, weil im Moment ist ja keiner. Sind wir beide die
Ich bin
Deutsch
an einem sehr lauten Platz im Moment.
ja, das ist kein Thema.
Versuch das mal zu ändern. 2, 3 Minuten bitte.
Ja, kein Thema.
Nein. Sorry, das habe ich ausgerechnet jetzt. Das ist immer das Gleiche.
Wir haben ja jetzt Nachrichten einmal geguckt, oder wundern wir jetzt aber nach oben?
Sind schmaler die Dinger? Lass das einfach mal so stehen. Esse das dann weiter, wenn ich wieder komme.
Du musst es den BIM-Ofen machen, glaube ich. Was machst du jetzt?
Ich gehe mal woanders hin. Weil jetzt kann ich gerade mit dem reden, weil wir ganz alleine sind. Die anderen sind ja alles im Meeting raus.
Ach ja. Okay, das ist beschäftigt, du sagst.
Ja. So, jetzt bin ich wieder da. Kann man mich hören?
Ja, ich höre dich.
Ja, okay.
Du kannst übrigens in das File reingehen. In den Instructions ist der Link zu dem
klasse. Ja.
zu dem File hier. Lass mich das mal ein bisschen kleiner machen, damit man das besser sieht.
Der ganze Teil Middleware, zumindest jetzt der zuletzt, wieso kann man das nicht in den ERP-Systemen machen? Also, oder anders gefragt, Middleware ist jetzt nicht gemeint als das Mainnet als Middleware, ne?
Nee. Das ist hier. Es geht hier rum. Das ist der Stack. Weißt du, du hast ein Interface Application Layer und dann erst hier ein Middleware Layer. Da hast du deine Workflows drin, die Definition von den Workflows, die Identity Accounts und Workgroups und dann Messaging. Ja, weil das brauchst du hier für, wenn du hier die Application Logic hier fürs ACL, ja, um zu checken, ob du die APIs callen kannst oder nicht. Ja, und dann hier Messaging. Das ist weil da ist eben die Frage, ist das eben nur innerhalb von einem Stack? Dann, was weiß ich, benutze ich Kafka oder RabbitMQ und dann kann ich das hoch skalieren, wie ich will. Ja. Aber wenn ich jetzt die Messages zwischen unterschiedlichen Vendors hin und her schieben muss, weil du zum Beispiel, du hast Bosch arbeitet mit Microsoft, mit dem SAP Baseline Stack zusammen und BMW mit dem Oracle oder mit dem Microsoft, ja. Dann musst du ja irgendwo Bosch möchte jetzt nicht mit Oracle, weil die keinen Bock drauf haben. Das heißt, SAP und Oracle müssen sich auf ein Messaging-Protokoll oder mehrere oder einigen, sodass ich weiß, dass SAP eine Message, die für BMW gedacht ist, von Bosch auch empfangen kann.
Ja.
No? Das ist die Frage. Und das Problem, wenn du P2P hast, dann ist das super gut, wenn du permissionless bist, aber wenn du weißt, wer deine einzelnen Vendors sind und weil die sowieso im Phonebook sind, ja, weil die sowieso im Telefonbuch drin stehen, dann kannst du auch sagen, dass du was benutzt, was besser skaliert als zum Beispiel P2P. Ja, sodass du da wirklich 10.000 Messages pro Sekunde durchhauen kannst. Ja, also nicht nur innerhalb von einem Stack, sondern auch replizieren kannst.
Ja.
No? Das ist die Frage. Aber jetzt hier so, mit wem arbeitest du zusammen?
Ich bin unabhängig. Also ich habe meine Firma verkauft und wir haben seit 2009 ein SAP-Add-on für Vendor Invoice Management.
Ja.
Alles inside SAP, also rein in SAP. Inklusive Interpretation der papierhaften Rechnungen, die gescannt wurden und dann OCR verhaftet wurden. So. Deshalb bin ich auch ein bisschen auf dem Trip nach wie vor, dass man das von den Backends her, also von den Endsystemen her steuert. Und was ich an Baseline halt total gut fand, ist, also, dass das nicht wieder über eine Konsortial-Blockchain läuft, sondern wirklich das Mainnet. Und
genau.
bin aber zugleich nach wie vor ein Anhänger davon, dass zum Beispiel das ganze Processing also gar nicht über einen jetzt kommt gerade aus der anderen Session, nicht gerade, aber war in der anderen Session, nicht über einen bestimmten Client laufen muss, sondern okay, natürlich in irgendeiner Art API vorausgesetzt, mit RESTful-Aufrufen einfach aus entweder Oracle und man unterstellt, die können das, SAP kann es jedenfalls.
Ja, Oracle kann das auch. Das ist kein Thema. Ja, das kannst du mit Hilfe von einem SDK und so. Das ist kein Thema. Aber die Frage ist, machst du muss ich als, was weiß ich, Bosch, was weiß ich, einen SAP Baseline Client laufen lassen und einen Oracle Client und einen Provide und einen Microsoft Client laufen lassen? Oder kann ich das, also was weiß ich, muss ich mich mit 4 Software-Anbietern auseinandersetzen oder 5 oder 6 für Baseline oder nur einen, weißt du?
Ja, aber das habe ich insofern jetzt auch aus der Diskussion vorher nicht ganz verstanden. Das ist doch eine Frage, die auf Protokolllevel definiert werden muss, kann.
Ja, natürlich.
So.
Aber
und in dem Moment, wo, sagen wir mal, Besu würde das nicht unterstützen, dann fällt Besu halt als Client halt raus.
Nee. Das ist Besu als das ist hier unten. Das ist hier unten. Ein Baseline-Client, der ist hier. Das ist der Baseline. Das ist sozusagen der Baseline-Stack. Das sollte ich vielleicht noch das sollte ich irgendwie als vielleicht nochmal irgendwie so kräftig
Mein Screen sharen?
Darstellen. Warte mal. Das ist ist nicht so gut. Warte mal, habe ich da noch was ich benutzen kann? Habe ich da eine Klammer? Ja, Klammer hier. Super. Das ist genau das, was ich gesucht habe. Das ist der Baseline Stack. Das ist der Baseline Stack hier. Das wollte ich nicht.
Ja,
das wird aber als höher, genau.
Ja.
So, das ist der Baseline Stack. So, und das ist hier eben alles nur Public. Und da hast du Probleme, du hast Probleme hier. Das ist nicht das Problem, das ist auch nicht das Problem, aber du hast, was die Transaktionen von angeht, ist das hier ein Problem, weil du im Mempool, das ist der wilde Westen. Und da geht es dann nur darum, wer mehr zahlt, und da gibt es dann noch 50.000 unterschiedliche Angriffsvektoren, die du da machen kannst. Du kannst dann Frontrunning, wenn ich weiß, welchen Smart Contract das kann ich da, also möglicherweise, also das ist dann Detaildesign für deine Smart Contracts. Da wird's dann wichtig. Und das ist eben, die Frage ist, also das ist fürs Scaling ist es wichtig, und dann hast du natürlich hier, da kriegst du die ganzen Transaktionen hin. Ne?
Ja, vielleicht bin ich auch etwa auf dem falschen Trip. Äh, sagen wir so, sämtlich ja, hatten eher High-Level-Slides von Baseline. Die zeigen ja, also von Daniel Norkin, die zeigen ja letztendlich, oder auch Konsensus auch, die zeigen ja letztendlich, dass an jedem ERP-System unten eine Schicht Baseline, wenn man so will, Plugin
Ja, genau.
was
Das,
genau
das hier.
dieser Stack wäre, ne?
Ja, das ist der Plugin. Der geht dann zum API Gateway. No? Das ist dein SDK, da hast du dann dein App, dass du einbinden kannst dass du dann zum Beispiel in dein Workflow, dein SAP Workflow einbinden kannst.
So, und ja, okay. Also ich sehe die Punkte da, aber vielleicht gefällt mir das nicht, dass ich nochmal eine extra Middleware brauche, um das Ganze durchzuführen.
Ja, das ist ja Baseline Stack intern. Du baust es ja nicht in den. Ich meine, du kannst das Ganze natürlich in SAP einbauen, wenn du möchtest. Ja, klar kannst du das machen. Nur du musst dann das
Messaging, das ist ein extra Punkt. Das ist logisch.
Ja, also aber du kannst das mit reinbauen, aber allerdings sind die Sachen hier, das musst du klar, das kannst du
das ist traurig, ja.
Da musst du richtig für arbeiten. Also das ist ein Add-on. Deswegen, das kannst du als SAP Add-on machen. Aber da brauchst du halt Techniken, die sozusagen nicht SAP Native sind. Ne? Das ist auch klar.
Ja.
No?
So, jetzt sagen wir mal, den Baseline Stack gäbe es als Stiftung. Ja, sodass
den gibt's. Es gibt eine Referenz Implementierung.
Das kenne ich alles. Aber sagen wir mal, das wäre wie in Führer nur kostenlos. So.
Ach so, du meinst naja, also kostenlos kannst es ja nicht machen.
Lass uns mal egal. Ja, klar, das soll ja nicht kostenlos. Aber sagen wir mal, das gäbe es und man könnte es aufrufen. Jetzt wird noch ganz getrennt dann wäre das eine API, wogegen ich meine Workflows, die Identity sowieso, das hatte ich verstanden, das ist ein Smart Contract auf der Public Chain. Messaging außen vor, das muss man dann definieren zwischen Bosch und was war das andere? Auch egal. Der Müllermilch von mir aus.
BMW hatte ich, das war das
BMW.
Beispiel.
Und dann
ja, also für Scaling ist das hier wichtig.
Das ist dann eine andere Story.
Das ist hier der Workshop hier, da geht's ums
Ja, ich weiß, deswegen, ich wollte eigentlich auch nur zuhören und lernen.
Also hier geht's um Scaling, da geht es eben darum, was du da benutzt, welche Scaling. Du hast eine Spreizung zwischen deinem Throughput und deiner Privacy. Ja, da können wir, das ist, weil du musst nicht alle Transaktionen unbedingt auf die Chain schreiben. Ja, das ist zum Beispiel, wenn du, was weiß ich, eine Shipping Notice oder sowas hast. Ja, das ist wichtig als Update das zu machen, damit du weißt, dass das da ist, weil wenn irgendwas später schief läuft, wirst du sagen, ja, aber hier Shipping Notice kam. Das ist wichtig, aber das muss ich zum Beispiel nicht als Zero Knowledge Proof auf der Chain haben. Da würde es reichen, wenn ich irgendwie eine URI auf der Chain habe, die dann, was weiß ich, zu einem Merkle Proof zeigt, und ich kann das sozusagen dann ist das irgendein Eintrag, ist die Shipping Notice ein Eintrag in einem Merkle Tree, und der Eintrag ist verschlüsselt, und das war's, ja. Dann hast du dein und das skaliert hoch. Wenn du allerdings zum Beispiel eine Rechnung haben möchtest, und die Rechnung möchtest du dann zum Beispiel fakturieren, ja, oder eine Bestellung, und die möchtest du dann zum Beispiel für einen Kredit benutzen, ja. Oder oder du möchtest eine Rechnung, die du bald bezahlt bekommst, benutzen für eine Bestellung. Du sagst, dass du, ja, ich kann die bezahlen, weil ich bekomme das jetzt. Ja? Diese Art von Geschäftsprozessen, da müssen die Dokumente sozusagen on-chain sein. Und da brauchst du dann diese Zero-Knowledge-Proofs. Na? Also, und da brauchst du dann für Skalierung brauchst du dann CK Rollups. Ja? Da reichen die Optimistic Rollups nicht. Ja. Also wenn es um Wertschöpfung geht. Und das ist, aber das heißt, du siehst dann, du brauchst dann im Endeffekt zwei unterschiedliche Arten, um deinen Geschäftsprozess sozusagen zu typisieren, oder beziehungsweise die Dokumente in deinem Geschäftsprozess. Also der einen, wo du das alles nicht on-chain brauchst, und Dokumente, wo du es on-chain brauchst. Ja. Und dann musst du die beiden verbinden. Und die Verbindungen sind dann, was weiß ich, dann sind dann Hash-Proofs oder Merkle-Proofs, die du dann als Input in deinen General Prover Service machst. Ich weiß nicht, bist du vertraut mit CK Snarks oder sowas oder nicht?
Ja, wir hatten ja diese Diskussion in dem Chat, wo du auch eben nicht so, also nein, anders. Das war ja schon damals in dem Chat meine Frage. Ja. Wenn ich noch anders gesagt, die Workflows, um die es geht, die müssten per Definition enthalten, welche Schritte unter welchen Bedingungen abgearbeitet werden, so dass zum Beispiel ein Lieferavis nicht übers CK-Proofs laufen muss, am Anfang die Bestellung zum Beispiel, aber schon, und vielleicht sogar der Wareneingang. In jedem Fall aber die Rechnung. So.
Ja, das ist die Definition für hier. Das ist die Frage, benutze ich dann ein Programm, so ein General Prover Programm, für ZK Rollups oder für ZK Snarks, ja, gegenüber zum Beispiel Optimistic Rollups. Ja. Oder kann ich sogar noch einfacher machen, weil ich ja da wirklich keine Wertschöpfung, keinen Wert auf die Chain schreibe. Kann ich das noch einfacher machen, indem ich einfach nur einen Pointer zu einer URI mache? Also bei Optimistic Rollups schreibe ich immer noch die Transaktionen, die Unterschriften für die Transaktion als Hash-Proof auf die Chain. Ja, das heißt, du musst dann gucken, ob du dann auch wirklich derjenige bist, der normalerweise ist der Nachteil ist, dass jemand dauernd drauf gucken muss. Weil wenn jemand einen Block reinschreibt mit einer Unterschrift von dir und du hast es gar nicht gemacht, ja, dann musst du gleich die Hand heben und sagen, nee, das geht nicht. Ja? Das ist nicht wahr. Du kannst...
Wie sollte das einer können?
Ja, du weißt ja, ob du was unterschrieben hast oder nicht. Da gibt es wenn du dir, was weiß ich, anguckst, zum Beispiel, ja, Optimistic Rollup-Varianten, zum Beispiel Validium oder sowas. Da ist die sozusagen die Grundbasis ist ja, dass du die Unterschriften von den Transaktionen als Aggregation auf die Chain schreibst. Und du hast aber nichts über die eigentliche Transaktion. Keine eigentliche Transaktionsdaten. Und das ist der Unterschied zu ZK Snarks. Bei ZK Snarks hast du das, weil du hast das Ganze in einen ganz kompakten Beweis reingeschrieben.
Ja.
Und den Beweis kannst du überprüfen, auch on-chain. Und das ist ja das Schöne.
Der Witz da dran. Ja,
das ist genau der Witz. Das heißt, du weißt genau, dass es richtig abgelaufen ist und dass das alles mit rechten Dingen zuging. Und dass der Operator kann den Beweis nicht fälschen. Während bei Optimistic Rollups, da könnte der Operator die Unterschrift fälschen.
Also ist das dem Prinzip nach doch keine Lösung.
Die Optimistic Rollups sind für zum Beispiel Bestellungen und Rechnungen keine Lösung. Da brauchst du meiner Meinung nach die ZK Rollups. Aber was weiß ich, für eine Shipping Notice oder Return Receipt oder solche Sachen, da kannst du eigentlich alles Off-Chain machen und musst dann nur in einfachen Anchor-Proof mittels URI und Merkle-Proof auf die Chain machen. Das ist alles. Und dann kann jeder das überprüfen und das ist relativ unproblematisch. Und dann ist ein Input-Parameter für dein ZK Snark, was weiß ich, ist dann, dass du für die Invoice muss dann eben eine Shipping Notice da sein, zum Beispiel. Und das kannst du dann ganz einfach über den Hash machen. Ja, und dann kannst du das reinschreiben und der Hash muss dann eben bestimmte Charakteristiken haben. Ja. Also, und das ist relativ einfach. Oder es muss ein Aggregate, was weiß ich, sein, den ich dann irgendwie on-chain, dass ich irgendwie überprüfen kann in meinem Prover-Programm, das ich für den ZK Snark geschrieben habe. Und das geht. Das ist kein Thema. Insofern kannst du die kannst du also sozusagen zwei Parallelwelten, einmal mit was weiß ich, mit diesem einfachen Batching oder non-financially sensitive Documents kannst du dann, da brauchst du wenig Daten on-chain. Das Problem mit den ZK-Snarks ist, dass du also, was ist es? Also ich brauche im optimalsten Fall, wenn ich ein ZK-Rollup mache mit 4500 Transaktionen, sind es im optimalsten Fall knapp 0,9 Megabyte Daten, die ich auf die Chain schreibe. Im schlimmsten Fall sind es 2,2 Megabyte. Das hört sich jetzt nicht unbedingt viel an.
Es wird aber teuer in der Sinne.
Aber das ist es ist nicht teuer von den Transaktionskosten. Du spammst die Chain. Weil du kannst ja mal machen. Mach das mal, wenn du 1000 Transaktionen, Rollup-Transaktionen machst, dann bist du bei 1000 mal 4500, sind es 4,5 Millionen Transaktionen. Das ist jetzt nicht so wahnsinnig viel, aber das sind dann schon 1000 mal 2,2 Megabyte, bist dann auch schon bei 2,2 Gigabyte. Und das könntest du gegebenenfalls locker am Tag abfackeln. Gegebenenfalls noch mehr. Das heißt, wenn du dann bei 4 Milliarden wärst, dann machst du es nochmal mal 1000, dann bist du bei einem Terabyte, dass du pro Tag drauf schreibst. Und das ist problematisch. Ja, weil dann ich schreibe dann alles drauf und dann so, wenn alle in der Welt draufschreiben, dann wird die Datenbank natürlich auch relativ schnell voll.
Ja, gut, jetzt folgendes, Andreas, aber für mich sind das wirklich Layer 2 Fragen, ne? Da kann ich kaum mitreden. Ja,
das sind die
ich weiß, dein Workshop geht eigentlich genau auf das.
Genau.
Ja.
Du kannst gerne bei ich wollte das einfach nur mal erklären, wie das aussieht. Ich warte, ob noch Leute kommen. Und wenn nicht, dann ist es anscheinend, dass keiner daran Interesse hat. Andere Sachen sind.
So nicht. Ich glaube eher, dass das vielen so geht wie mir, dass man erstmal die Basics von Baseline mehr verstehen muss. Das ist, was du gerade ausgeführt hast, entscheidend wichtig.
Ja, und das stimmt.
Ich meine, ich folge dem Baseline-Projekt seit Beginn, also seit März. Und das ist nie aufgekommen so. Ne?
Nee, das ist richtig. Aber das ist ja die Kernfrage ist, zum jetzigen Zeitpunkt kostet dich jede Transaktion irgendwo zwischen $2 und $4.
Ja, alles gut. Jetzt einerseits, das mag für einen Bosch oder BMW aber auch nicht viel sein, weil für Invoice Verification geben sie
aber überleg mal,
aus.
wie viel Bestellungen macht Bosch am Tag? Stell dir mal vor, wenn du 10.000 Bestellungen durch Baseline durchlaufen lässt. Allein nur die Bestellung, das kostet dich dann 20 pro Tag. Das kostet dich dann $20.000. Das ist viel Geld. Stell dir mal vor, für eine Bestellung, die ich faxen kann, ja, quote unquote faxen oder e-mailen kann, das kostet mich ja nichts quasi. Ja. Da muss ich $2 für zahlen. Da guckt dich der Finanzvorstand aber ganz, ganz schnell, ganz, ganz schräg an.
Gut, einerseits, andererseits, so ist es im Moment wegen den High Gas Prices. Right?
Ja, aber das wird sich ja nicht ändern. Das wird ja, das wird ja höchstens schlimmer. Ja, das wird ja, als es ganz schlimm war, als DeFi ganz, ganz oben war, hast du, wenn du Fast Confirmation, musstest du $200 oder mehr pro Transaktion zahlen.
Ja, okay, das ist ganz große Finanztransaktionen.
Ja, du hast die Abhängigkeit.
In der Masse wird es nicht machbar.
Ja, aber das ist eben, genau, das ist eben das Problem, das ist die Problemstellung, wenn du wenn du ein Protokoll benutzt, wo du als dein Anker, wo jeder drauf zugreifen kann. Und wo andere Programme auch laufen, die gegebenenfalls höhere Priorität haben als deine. Du kannst dann, das ist ganz toll, ja, wenn du sagst, ja, Public Infrastructure und alles Mögliche und alle finden das ganz toll, aber dann mal gucken, wenn du eben Rabauken hast auf der Autobahn, dann ist die Autobahn auf einmal auch nicht mehr so toll. Und das ist genauso mit Ethereum. Ne? Das ist also im Mempool, das ist absolut der wilde Westen. Wenn du mal guckst, was da abläuft, das ist unglaublich.
Ja, das habe ich auch, das verstehe ich alles, ja. Das ist
und deswegen ist es sehr kritisch, oder ist es extrem wichtig, dass du dass du die Transaktionspreise runtertreiben kannst, damit ich eben, was weiß ich, $600 für eine Transaktion bezahlen kann. Und dann kostet es mich aber trotzdem irgendwie nur 10 Cent oder 1 Cent oder noch weniger.
Ja.
No? Das ist der Krux an der Sache.
Dann ist aber das Fazit eigentlich,
Baseline zum jetzigen Zeitpunkt ist nicht skalierbar. Das ist ein Spielzeug. Ja, ohne Skalierung ist Baseline, ist es nicht wirklich benutzbar. Ja, du kannst jetzt das Prinzip demonstrieren und das funktioniert auch und du kannst das als Proof of Concept und so, das ist alles gut und schön, aber in der Produktion, wenn du da wirklich anfangen möchtest, ich meine, wenn du es nur für zum Beispiel benutzt für Bestellungen über 10 Millionen Euro oder sowas, ja, dann kannst du das sicherlich benutzen. Wenn du dann nur was weiß ich, 2, 3, 4 Transaktionen am Tag hast oder so, und die sind alle extrem hochwertig. Ja, also mit einem sehr hohen Betrag. Dann kannst du das, dann ist es okay. Aber
ansonsten, das ist aber im Projekt. Meinst du wirklich, dass das im Projekt so verankert ist? Was? Diese Ansicht? Oder dieses wirkliche Problem? Ist ja aber auch egal. Jedenfalls, das stimmt, das ist in gewisser Hinsicht, Stand heute ist es ein Showstopper.
Ja, klar ist es einer. Deswegen habe ich ja den Track ja auch gemacht. Und deswegen habe ich das ja auch als Business-Motivation reingeschrieben. Wenn das keine Leute interessiert, ist das so, kann ich auch nichts für.
Nochmal, das glaube ich so nicht. Man kämpft so wie ich eher mit den Basics des Proof of Concept.
Ja,
zumindest jedenfalls alle, die nicht unbedingt in den Prototyping drin sind im Moment. Ja, ich kann dazu ja nichts liefern zum Beispiel.
Ja, klar. Ich meine, das ist schwierig, wenn man jetzt gerade erst anfängt, da erstmal durchzusteigen. Ich meine, der Stack ist nicht gerade, der ist komplex.
Ja, leider. Ja so. Und das muss man mal durch die anderen Tracks gucken irgendwann.
Die anderen Tracks, die sind mit Ausnahme von den Core Interfaces, ist es eben, die sind High Level. Da ist wirklich der Phonebook und was weiß ich, Tokenization und so. Ich weiß jetzt nicht, wie es mit Tokenization aussieht. Müsste ich dann mal.
Naja, das ist ja auch noch nicht ausgegoren.
Mal reingucken.
Das ist,
Ja, klar, aber da brauchst du diese Zero Knowledge Proofs, um dann du musst die ganze Smart Contract Architektur muss geändert werden, ja. Die Baseline Smart Contracts die können ja noch nicht mal abgegradet werden. Das geht ja alles nicht. Du musst das komplett neu implementieren und das ist ja Schwachsinn.
Ja.
Ja, das heißt, da muss auch drüber reden. Das will auch keiner, beziehungsweise will schon, aber du brauchst dann eben Leute, die technisch wirklich versiert sind, um diese Diskussion überhaupt führen zu können.
Ja. So, ja, wie damals in dem Chat schon, es wäre überhaupt mal schön gewesen, wenn das Protokoll zumindest mal in den Grundzügen, also das, was
ja, das ist ja das, was Dan
auch macht gerade, das mal wie high-level-mäßig auch immer zu definieren in seinen Steps und fertig.
Ja, ich meine, deswegen gibt es ja die Standards Working Group. Da wird das ja jetzt gemacht und da werden die Standards jetzt festgezurrt. Also das ist ja jetzt alles am Anfang, ne? Und es gibt eine Reference Implementation, das war's. Ich meine, und ist das einfach? Nee. Weil du hast die unterschiedlichen Komponenten und die sind alle nicht trivial.
Ja.
Ist nun mal so. Ja, kann ich auch nichts machen.
Nee, das ist ja wie soll es auch anders sein? Das ist ein Feld eigentlich vom Himmel.
Ja. Jordan, my friend.
Yeah. So we switch to English and I go to listening mode?
No problem. I had a question, that's why I came to this session, but
yes, sure.
I'm
go
not
ahead.
sure if I'm interrupting you because I
No. We're kind of winding down.
So this is about the improvement of the baseline protocol, or
yes, this is performance improvement in order to get the transaction costs down.
Okay, yeah, I have what I don't understand is, say there's a frequent mention of this baseline being a public Ethereum blockchain, right?
Well, baseline is a stack on top of the public Ethereum. Yes.
Okay. So
let me share. Let me share. Resume sharing. Can you see my screen?
Yeah.
So think of baseline. So baseline are the first three layers. There's the interface application layer, there's a middleware layer, and there's a processing layer.
And then everything is written in the Ethereum blockchain, supposedly. Yes. Ethereum. Okay.
Yes, exactly.
Now let's go to Ethereum 2.
Okay.
Eventually it's going to be on Ethereum 2, right?
Yeah, but I mean, right, ETH2 phase 0 is just the beacon chain.
Yes. Okay, but there's one great inefficiency that I see here. Basically, all you're writing to the blockchain is a bunch of zero knowledge proofs.
That is correct.
Well, zero knowledge proof doesn't have to be idempotent, like spending money. So think about, you have one Ether, you go to one shard and spend it, and then you go to another shard, you can't spend it again. So there has to be a lot of work done, and thus the complication of Ethereum 2, for those shards to sort of eventually sync up, whether it's optimistic rollups or ZK, doesn't matter, but somehow they have to get in sync, so you cannot spend that Ethereum twice.
That is correct. That's why you have.
That's right. But you don't need that in the baseline.
No, you don't need that in.
So if you submit a zero knowledge proof twice, there's no problem. So you can submit it in 2 different shards. So
Oh,
eventually,
yeah. Totally. For baseline, even for scalable baseline, you don't need ETH2.
okay. So basically, baseline can be a completely independent chain, or so to say, independent shard, whereas the eventual syncing, it'd be special kind of, so to say, no sync shard, where at the end, instead of rolling up, you just put a snapshot of the last block hash into the main chain, and that's enough. So that kind of shard obviously cannot spend money. You could be just no idempotency guarantee shard. This way, and I don't think Ethereum 2 provides for that. So might as well just run a separate blockchain where eventually, only once in a while, you record the last block hash into the Ethereum. You get the same safety, and the cost is just much lower.
Yes, of course. You can run a separate blockchain. You don't even need to run a separate. You don't need to run separate. Multiple nodes. You just need to run one node. You just need one operator.
And sync it up once in a while. Yeah. So
that's exactly what layer 2 does, right? Like ZK rollups, optimistic rollups.
Well, you don't need the rollups. What I'm saying is you don't need the rollups.
Well, you need the syncing but it needs to be
need simple syncing and no rollups. Yeah, you just need simple syncing and no rollups to guarantee idempotency, which could make it a lot cheaper if you run just baseline.
So it depends on what you want to do with your commercial documents, right? So for example, if you have an invoice, right, and you want to create a loan against that, right, and then you're actually right. So you're tokenizing an invoice, or you're using an order as collateral you're using an invoice as collateral for an order, right, that you want to place, right? So the challenge there is that you need what's called data availability, right?
Yeah.
So you're at the in normal like with optimistic rollups and or batching, or where you have just a pointer, a URI pointer anchored on chain, right, and where you point back to another blockchain. I'm totally at the mercy of the operator, of the blockchain operator, or operator in general, whether it's 1 or 2 or 3, it doesn't matter, or 200. The advantage for a zero knowledge proof that you anchor is I can actually use that proof as soon as it's confirmed on chain, right, on the public chain. I can use that and utilize it somewhere else. So I can use that for tokenization, or if I get censored by my operator, I can just simply exit that arrangement and transfer it to another operator, right? But that only works if the critical data about the proof of correctness of my commercial documents, right, if that is on chain.
Absolutely.
Not on the, and that needs to be on the public.
Not on a copy, yes.
That doesn't need to, not on a private chain. You're right, I can achieve higher throughput and everything, but the question is, what is being written onto the public chain, right? And what am I intending to do with that particular commercial document? If it's a shipping notice, I don't really care. If it's an order, or if it's an invoice, or if it's an investment contract, I certainly do care. Right?
Yes.
Then it becomes important that I cannot be censored. Right? It's like if your bank, I
fully agree.
closes your account, right? You're SOL, right?
Mm-hmm.
Right? That cannot happen, right? I can't, it's like if you're telling a company, oh, by the way, I can prevent you from using that invoice in factoring or something like that, right? Then they're gonna go like, what? Are you kidding me? Right? So it's really important to decide what data is being written on chain, right? And what not, right?
Certainly, maybe this is a case to sort of talk to the Ethereum group to create a special provision for sync-only shards.
You don't need that. That's what a rollup is for. A rollup is nothing but a sequence of proofs that are then handed out to the owners, and you can prove at any moment that the asset the state of your asset is true, is correct, that you haven't double spent it, etc. Right? That's the whole point. And you're reducing your transaction costs, right? Because if I have 1,000 transactions, 1,000 zero knowledge proofs that I want to write on chain, if I do that as 1,000 transactions, right, that could cost me like $600,000, right?
I fully agree. Yeah.
Versus if I roll all of them up into one roll up, then it's like 60 cents per transaction, right? It cost me 600, right? It's a factor of 1,000 less. So that's why rollups are from a scaling point of view are important.
Yes, what I'm saying is the current implementation of rollups, or basically requirement, not implementation, requirement, is that at the end, this whatever transpired on that shard is transferable elsewhere. Whereas the requirement of the base chain is a lot smaller. You don't really care about transferring everything. You're just recording information. So see, and if you're spending Ethereum, you have 2 shards, and you spend the Ethereum in both shards. That's complicated. So somehow there has to be a sync there. Either you transfer the Ethereum to one shard and spend it there, or somewhere in the middle of everything, do a cross shard sync with whether it's zero knowledge sync, doesn't matter. But that's where it's expensive. And for the baseline, you don't care if you write the same proof twice, or in one shard, or in many shards. So the rollup.
Actually, I do care, depending on what I want to do with the document. Sorry for interrupting you, but I actually do care. If it's an invoice, I care.
If it's an invoice, you care. But if the invoice has a unique identifier, the zero knowledge proof of that invoice is unique. Let's say. Let's make it simpler. Are you familiar with Tornado Cash?
Mm-hmm.
Okay, so it's a very simple case. I deposit money into it. It gives me a proof. Mm-hmm. That proof is mine. It's a string, and that's not generated on chain. By the way, it's generated in my browser. So I have the proof, and as soon as I submit it, they put a nullifier on the chain. So all the verifier has to do is, if this was on Ethereum 2, they don't care which shard the proof is on and which shard the claim is on.
Mhm.
The proof is unique.
Yeah,
So
you have
if
an-
it's an
you have an
invoice, same
SPE.
thing. You same invoice can be written twice, but that's a uniquely identified invoice in the ZK proof. So you don't care if you put it in two different charts. And if there's a modifier or nullifier, just like the nullifiers in Tornado Cash, no problem. You can put them twice. Only the first time nullifies it. The second time doesn't matter. And this could make, Ethereum 2 is Ethereum 2 shards are almost an overkill for this kind of a system. So maybe this is a case to propose to the Ethereum group a special kind of shard that is just proof only, no syncing.
Yeah, I mean, you can create any shard that you want, and you can register that shard on the beacon chain, right? No one is preventing you from doing that, right? That's entirely you can write your own execution framework, and that's perfectly fine, and you're syncing to the beacon chain and on at certain times. So the challenge is not the document, is not the invoice. The challenge is if you're let's say you convert you're linking an invoice to an investment contract, and that investment contract is then tokenized, right? So at that moment, right, and then I'm selling the units as a what, it's an ERC 1440 or something like that.
Yeah.
But I'm aggregating, let's say, multiple invoices, let's say 1,000 invoices into that security, right? Which I can. It's not that
No problem.
right. I have the proofs that I do. There's some metadata that I need to write into that, but that's it, right? So I'm not worried about the invoice itself. I'm more worried about the once I've tokenized that commercial document, or that set of commercial documents, that then I don't have double spends, and I can choose, right? It's like I can do a very, very simple anchor proof, as you suggest. If I do not intend to tokenize the invoice, right, then I'm perfectly fine, and I don't care if I don't get the data back, right? Then that's perfectly all right, right? I don't need to worry about that. Then I don't even need to generate a ZK snark or anything like that. Then I just need to put an anchor hash that's a URI that points back to some content addressable storage that has a Merkle tree in it, and a Merkle proof, and one of the leaves is the encrypted version of your invoice. That's perfectly fine, right? As long as you don't want to do anything else with it, right? Because you're not putting any PII or any sensitive information on chain, because you're aggregating multiple documents from different business processes into a Merkle tree, and you're using the Merkle proof as an input, right? So your URI on chain points to the Merkle proof, and the Merkle proof has the Merkle proof plus a pointer to where all the leaves are, right? And then you can validate that, and then you have URIs that point to actually where the actual documents are stored. So that's entirely fine. That's entirely doable, and you can use the same concept of validating documents by having smart contracts that have all of these characteristics in that need to be validated, address, blah blah. You can make that as complicated as you want, and you're using like an OVM for that, right? And that's perfectly perfectly fine. You're generating the output, and the output goes into as a leaf into the Merkle tree, and you do it, and you anchor it on chain, and you're done. You are absolutely right when it comes to that. If I do not want to use those commercial documents for anything else but that, I'm totally okay. That's perfectly fine. As soon as you want to use a commercial document, that is going to be used for anything that is related to on-chain tokens, then I need that data on chain. At that moment, I do.
Mm-hmm.
Right?
And so what if they're duplicates?
Huh?
What if they're duplicates of uniquely identifiable things? You don't care.
Well, actually, you do. You cannot use an invoice twice in a financing transaction, right? I can't factor an invoice twice.
Yes. If that copy, if you have a duplicate of the proof, that's not two invoices. It's one invoice.
Yeah, but if I use one invoice twice, if I use the same unique identifier in two different financing, in two different investment contracts, and let's say they were on two different shards, then I have a problem.
But in the baseline, you're not putting out any transactions. In the baseline, you're just putting proofs, right?
Yeah, but you're using that proof in the tokenization, because if you need to, and that's what the tokenization working group is going to do. It is talking about what type of baseline native data needs to go into the smart contract for the token. Does that make sense?
Yes. So there's tokenization where it actually has to be synced. Mm-hmm.
Yes, that is indeed true. Right. So you need a hybrid system, right?
Mm-hmm.
Where you need to decide whether a specific document is supposed to be tokenized or not. If it's tokenized, if it's not tokenized, you don't need to jump through all the fancy hoops of a ZK snark and a zero knowledge proof and validation and what have you not. But if you do, right? If you do, then you need to anchor that proof. And you can even make it fairly simple. You can decide whether you want to put a ZK snark proof on chain or whether you want to store it off chain and then just put an anchor hash on chain, right? If you don't want to run like an optimistic rollup stack and a ZK rollup stack at the same time, you could just run like ZK rollups, and you only put certain ZK proofs into the ZK rollup, and the other one you just store off chain and then anchor it on chain, so you don't need to do the same thing twice.
Okay.
Right. So you're right. In one case, you're putting the actual block with everything on chain. In the other case, you just put the pointer to the block that you have created with the ZK rollups on chain, and the actual block with everything is kept off chain.
Mm-hmm.
Which works too.
So this baseline, what does it contain? It contains not just proofs. It contains tokens as well, which are public.
That's what they not right now, but the value, the big value for organizations, right, is to be able to finance their invoices in real time, right, if they want to, right? So that is enormously valuable if you are talking about cash flow management. right? Or if you imagine you can do now repos without being a bulge bracket player, right? Because overnight paper market, if you're not starting like at a couple of billion, there's like, nah, don't do it. So here now you can do that, right? You can do repurchasing agreements with much smaller quantities, and so sort of like you have a secondary market for repurchasing agreements, and at much lower cost because you're doing everything on chain, right? So you have roll ups, the transactions cost are significantly lower, et cetera, et cetera.
You can do anything on chain a lot cheaper than with the banks. So
right, exactly. So but even if it's a regulated entity, you can show that you're, a repo, right? If you're looking in the US, I'm just talking about the US right now.
Okay.
For a repo, right? A repo, there's the overnight paper market is really individual transaction. There's no market per se. It's not an exchange, right? So what do is you're calling someone up and it's like, hey, can I, it's like, can I have like a couple
over the counter? Yeah.
Right. It's over the counter, and there's a third party in there that ensures that the promised the securities as collateral, or the collateral that you put in for the repo is not double spent. Right. So you can do the same thing now that you do, but the third party, which is now often like State Street or Mellon Bank or so forth, you don't need to do that because you have your proofs of non-double spend on chain, right? And so your third party becomes your public chain, and that's just the promised collateral, and then you're aggregating that into the repo, which means you can do this now at much quicker and at much lower cost, right? Because the third party in the middle becomes significantly more. The only thing that they need to do if State Street were to run a baseline stack, it would be a very cheap solution for low value, quote unquote, lower value repos. Or you could aggregate repos into smaller repos into a larger repo, right? So there's all kinds of new financing options that you all of a sudden open up, right? But again, for that you need to decide what do I want to use for tokenization and on-chain stuff, and what do I not need, right? And the key thing is all driven by reducing transaction costs, right? Because again, a ZK rollup, you don't have to put a ZK rollup on chain. Right? The block, you can just put a pointer to the block on chain and keep the rest off chain. Right. The reason why you put the entire block on chain is because you want data.
You need the chain as the proof. Yeah.
You need the chain as a proof. But I can go, left bucket, right bucket. Left bucket is off chain. Right bucket is on chain, and I only anchor the left bucket once in a while, on chain. That's it. As you suggested, right? So it's just a hybrid solution.
See, in Ethereum too, basically, if you run your own side chain, the problem is you don't have many miners or stakers. We'll call them stakers now. You don't have enough stakers to actually assure that it's the source of truth. You may modify it if it's just your own private thing or with a few participants. Whereas on Ethereum shard, basically the stakers are randomly chosen to go and verify any block in any shard. They don't even know in advance. So basically, all shards are source of truth. So the problem with Ethereum is if you run a shard, it's not your own shard. It's for everyone. Anyone can go into that shard. And if it's for anyone, then these proofs will have to occur, and that incurs cost. And that cost is shared among everybody because the stakers, that's what it costs.
Yeah,
Whereas if you
I'm not
able to run a
disagreeing with you.
shard. Mhm.
I'm not disagreeing with you. So it's like if you want, if you have multiple options, right? You can just launch a new shard and make that public, and that's possible, right? To invite stakers in there. That's all good and well. Or you could have it federated and it's just registered on the beacon chain, and there are all kinds of different options out there. I'm just saying that for a scalable baseline solution, you don't need ETH2.
No, you don't.
Necessarily, right? So I'm saying you don't have to wait for ETH2 to have a scalable baseline stack.
You could have ETH1 act as a beacon and your own chain. Yes.
Yeah, or your own single operator, right? If you're doing it, it's just that there are trade-offs, right? If you're using ZK rollups and you're putting the rollup on chain, then you're okay with having just one operator because the operator can't do anything. If you keep the blocks off chain and just anchor it through a root hash, then you're relying on the trustworthiness of your operator, which is fine depending on what you need to do, right? It's like what documents you're baselining.
Now this beacon chain, this baseline is not a two-party system. It could be multi-party, like an auction, right?
Oh, if you want to run it as an overlay network, yeah, sure. I mean, if you wanted to, if you have something that needs consensus somewhere, sure. It's like you can run the baseline stack as a sidechain, right? With a faster consensus algorithm, you use just a proof of authority, and you only have like 5 nodes and 3-second block times, and you're good to go. Right? It's again the technique that you want to use based on what use cases you want to be able to map to.
Yeah.
Does
It
make sense?
Yeah, it makes sense. So this is not your problem. The Ethereum 2 needs sort of duplicate agnostic shard feature, which they don't have.
Well, it doesn't really need to. You can use any public shard as your anchor, right?
Well, as long as it's public, it's expensive for you because somebody else is doing expensive stuff on it.
Yeah, but it's well, if you're the nice thing is you can just switch a shard if the shard gets crowded,
Switch
right?
to cheap, yeah.
So less crowded.
Fishing for cheap shard. But
yeah.
see there are 64 shards. You can switch shards all you want. They're all going to be more or less as busy as any other, because there'll be transactions that have to be idempotent on each shard.
So Tas, it's like you're very close to that. I see that you'll have shards that are focused on specific use cases because you don't want to have cross shard transactions because they slow things down, right? Tas.
Yeah.
If you want to chime in here. I guess not. Yeah. So I think that there'll be shards will naturally, in my opinion, will sort themselves into
you know, specific purposes, right? Things that are more focused on, I don't know, supply chain. The other one is going to be, or there's charts that are going to be focused more on DeFi. I could very well see that there are different, you know, incarnations of like DAI across different processing centers of DAI across shards. And you know, it's like you have then, you know, we can transfer between shards, but you know, it's I think that is going to be that is what's going to emerge, because you know, if you want to have, you know, you want to have DAI and you want to trade and you want to use DAI and Compound and Uniswap, you don't want to do that cross shard. You want to do that within one shard.
Yeah, it's a big question, but
yeah,
have yet to see how Ethereum 2 shows up.
Yeah, I don't really, from a baseline point of view, I don't really care.
You don't
to be
care,
honest.
huh?
I mean, why would you
Oh,
care?
no.
Why
Right,
would you
right.
care?
For now, it's pie in the sky now, so it doesn't really. By the time Ethereum 2 comes, baseline will do improvements too, so nothing to worry about now.
Right. So are there, you know, here we have this key question that we're looking at. So transaction scaling versus transaction cost versus network impact actually versus security. I have that. Right. So how does baseline impact permissionless network throughput and transaction pricing? So I think so I'm really wondering if we're using, so if we're talking here in terms of mempool, VSM and storage. I think the interesting question here is the mempool from a security point of view. Right, because when you're writing a proof, or when you anchor something on chain, right, you're throwing it into the mempool, right? So the question is, what are all the bad things?
Take advantage of it, yeah, before it's mined.
That can happen there.
Well, that's why it's zero knowledge. So whoever wants to take advantage of it, they can't find anything else about it.
Yeah, but you know the contract, right? Right? Can you censor a baseline contract? Right?
Okay.
The question is that
before it gets to the chain, can a staker do that? Question, huh?
Yeah, it is a node, right? Can I censor? Can I censor or front run baseline transaction?
Censor not. There are many stakers, but front run. You can front run if you know what's in it.
So let's break this out into two. So this is front running. And the other one is censoring, right? Oh wait, wrong one. Censoring.
You don't have to worry about censoring.
Let's just
have it there, yeah.
I just would like to I would just like to
be complete.
Be complete and have it there. Let's talk about, so if it's easy, let's talk about censoring first. So, really the question is, so really what you need is really a, you need, transaction fee has to be high enough, right?
Yeah. Yeah, that's one thing. Neither of these consensus protocols have fairness in them.
Right.
That's that's
But
something
is
I think it will be revisited in the future, not by baseline, but by blockchains. By block developers.
so the other question that I'm seeing is, can I collude to censor baseline transaction? Can I collude to censor? Right. So let's say someone says, hey, there's like an investment contract for like $1 billion on the way. Right. So if someone spills the beans,
and then somebody tries
Insider.
to slow down everything. Yeah.
I mean, we don't have to answer that necessarily right now, but at least this is the question. I mean, can I collude? So really, so it's a form of preventing transaction based on insider information about large value baseline transactions.
So not all transactions on baseline are zero knowledge.
No, they are. But if I tell you, right? So if you get the zero knowledge proof back, right? And you communicate that out as a transaction is submitted. I mean, there are bots scanning the mempool all the time, right? There was a great story about a Uniswap bug. There were like $12,000 or something like that were locked up, but in order to unlock them, you needed to submit 2 transactions, and they would have to be in the same block. But they couldn't figure out how to do it in the same block and submitted it into 2 separate blocks. And the second transaction of them was front run, and someone swiped the $12,000.
Uh-huh.
So the point is there if I know that a particular proof is in a block, right? Can I extort someone long enough?
Can you slow them down long enough?
Right. So to for example create a competing one. Right.
So you could delay it perhaps, but it's gonna, if it doesn't get in one block, the next block is gonna be mined by a different validator, and you're not gonna know which validator is gonna mine it. So it's gonna be hard to get all the validators to collude to keep it censored for a long period of time, wouldn't it?
Well, it depends on what the MEV is, right? The minor extractable value.
You could end up paying more and more and more fees to get always ahead of that transaction that you want to slow down.
Well, let's say even 50% of the validators are colluding. If you wait a few blocks, you're bound to get your transaction assigned to somebody or mined by somebody who's not colluding.
Right.
Oh, the miners don't have to collude. It's say you want to interfere with the entire baseline. You know something's going to happen in the next minute. and then you just want to throw transactions in a mempool that are ahead of whatever's coming from baseline.
Oh, you could delay it, but I don't think you could prevent it from
You could delay it, yeah.
happening
You could
eventually.
delay it for a long time. Just pay more.
It would be pretty expensive, but yeah.
Yeah, well, if the baseline transaction is $1 billion transaction, you can end up paying those pennies.
Yeah, well, you might delay it by a few hours, but
Uh-huh.
I don't think you'll stop it.
So if you know what's actually in there, right? So if you're doing trading, right? I mean, you can yeah. So it's like you could front run it, right? So this is
You could delay it so you have enough time to front run it.
right.
Yeah, let me do it like this. Let's talk about front running. Right. So you can inject you could inject a transaction that sort of like so what can you do in terms of front running if you know that a transaction is included in a baseline transaction in a block, right? In a block of transactions.
You keep on paying more and more to get ahead of with transactions that just gonna fill up the mempool ahead of that transaction until you get enough time to front run it.
Well, what's the final outcome, right? You want to subvert that. You want to you have two options, right? It's like one is you want to you want to make the transaction meaningless, right? For example, by doing a trade first, right? Or alternatively,
What kind of a trade could you do that makes it meaningless?
so for example, let's say you want to sell an asset-backed security, right? And I see that, and I have insider information. So this is like insider trading.
Yeah.
Right. So I have insider information about that baseline transaction, which could be a tokenization transaction.
Okay. So yeah, that makes sense. So when you're talking about like front running a purchase order, that probably doesn't make sense. But if you're talking about tokenizing stuff, then yeah.
Yeah, exactly.
If the asset is non-fungible, certainly you can grab it before the other party can.
Yeah, the tokenization.
Right. I mean, the challenge is like you would need to. I mean, if it's just a zero knowledge proof or it's just a pointer, you just need to have specific information. And then what can you do? You could submit. What can you do? You could submit an alternate block. I think that's pretty much the only thing you can do, no? In terms of front running, you can't really inject a new transaction, right?
Well, somebody could like if you're trying to purchase a token, somebody else could come along and purchase a token with a higher gas fee.
Yes, but that is already when you already have a baseline token, so to speak.
Yeah.
Let's just go concrete. Suppose eBay auction and eBay is on baseline. Auction is ending now, and you want to buy that item cheaper. So you bid, and then you put stuff in the mempool ahead of the rest of the people.
Yep, you can do that.
So they cannot catch the deadline of the auction, and the auction finishes, you get a better price.
Yep.
Yes, but that is already out. That is sort of like already that is like, so you have turned your baseline asset into a token, and then you're putting it into like a DeFi protocol, like an auction protocol, right? So that's the auction itself. I'm thinking about the actual baselining transaction. Right? Is there if I know that there's a very large tokenization transaction, right? So there's an investment contract being created. Is there a way to front run it?
If the two parties already have a consent, there's nothing you can do. But if you're competing with other parties, you can always front run, slow the others down.
Yeah. But that's really, I mean, front running is really injecting yourself, getting yourself ahead of the queue, right? And doing that. I think what you could do is spam the it would be spamming the baseline contract. Do you know what I mean?
Just to delay it.
Yeah.
Yeah, you could delay it. Mm-hmm.
Right. So that would be, I think this would be like really it would be more, there would be more spamming, right?
Mm-hmm.
But that would that can be avoided if it's permissioned.
Mm-hmm.
Right. I mean, you could in principle, like, yeah, but then you would have to spam the entire net. You would have to DDoS the entire network, right? Mm-hmm. Alternatively, is spamming the entire network, right? But that's expensive,
mm-hmm.
right? That would probably be cost prohibitive, right?
If you want to keep it up for a long time, yeah.
I mean, everybody and their cousin would start screaming.
Mm-hmm.
Now the question is, it's like it depends on if you know that there's a lot of value at risk, and if it's time sensitive, then that could be an option. But otherwise, I don't think that's it's relevant.
Yeah, and it would be hard to know when a transaction is about to be sent to the network. As well.
Yeah, you would have to have insider information. So I think yeah. So I think that's done. permission, and you could also do staking.
Oh, right. Put up a bond.
Right, it's like bonding baseline operators. So those are, I think, the most effective. So you can say, well, I can pretend to be baseline operator, and then I'm like spamming the hell out of the contract, right?
Mm-hmm.
If I know, because I have permission, I have write rights.
How do you prove that somebody's spamming and should be punished?
So you can do that by, for example, I could actually show you a piece of code that I wrote. You can require that, for example, every operator is only allowed one transaction per block.
Mm-hmm.
So you can check. So if the first transaction comes in and is processed, right, the next one that comes in, if it comes from the same operator, right, and you just simply check. So you increase the counter, right, internally, right, but the block number is still the same.
You're talking about layer 1 blocks or layer 2 blocks? Layer 1 blocks. Okay.
Right. So the block number is still the same. So if you just check, you know, is this number higher? Was the message.sender the same? Mm-hmm. And if the block number is the same, you immediately slash the entire bond.
Okay.
Right. And
you can have a third party helping you.
Huh?
That doesn't help you. You can have a third malicious party helping you.
Yeah,
Say,
but that
nice
one would have to be, you would have to stake, you would have to bond that third party too. And if you're saying, well, you know, baseline operators are high value operators, and you're requiring, like, I don't know, like 40 or 50 ETH or 100 ETH to be staked, that gets expensive pretty quickly. You would have to be registered as a baseline operator, and then you have to
on a public blockchain. But on a public blockchain, only the attempt counts. So it doesn't matter if they fail. Say in the smart contract function, you have some kind of a guard that guards that only a member calls it. Who cares? A malicious party can just go in and spam it with calls that fail, thus slowing the whole thing down, and you don't even know who they are.
Right, but they then still have to pay I mean, that's spamming the entire network, right? It's not just a contract; it's just spamming the entire network. Yeah. Right? You're at that point. It's like you're spamming. You're spamming the entire network, and if you know, and it's going to do, you know, and if you have the code as an assert, not as a require, not as an assert, or you have it as a revert, then it actually costs you a lot of money. Mm-hmm. Right, because then the entire it's not like it's going to get refunded. So I think the combination of sort of like permissioned writers and bonds would make it sufficiently, would only leave like trying to DDoS the entire system to get to slow down a transaction, which could be worth it if the transaction is super valuable. Right, but in a high price environment, that's, I mean, you know, DDoSing Ethereum when you know the transaction fee was like, you know, 10 cents a transaction, versus now where you could easily get like $20, $30, $40, $50.
Yeah,
the
and we
transaction.
just don't see it happening really.
Yeah. You don't see that happening. It's just not worth it, because it's just the value is just in slowing things down or preventing it from happening.
Mhm.
Since there's no direct on-chain value unless you've tokenized something, it's not really something you can really influence.
Yep.
So I think that's
so you're talking about this tokenizing and dealing with tokenized assets on layer 1, but should the layer 2 solution for baseline also be able to handle tokenization and tokenized transactions of tokenized assets?
Mhm.
So does that imply that the layer 2 solution should support general computation?
Mhm.
Okay.
So I mean, this is here virtual state machine. So one of the requirements there is for sure is that it supports general computation.
Okay.
Right. Which could either be in zero knowledge or not.
Mhm.
Right. I mean, so the question is, can you see the so what are the so the interesting question is about visibility of data.
Mhm.
Right. So can I what can I see? Right. What can I or what can the operator see?
Mhm.
Right. Does the operator, is it okay? So the key question here, I think, is, can the operator see like input data? Right. Or is the operator allowed to see the data in the clear?
The tokenized transactions.
Yeah, or any transaction, right?
Yeah. Well, the zero knowledge stuff they won't, but it's transactions with tokens they could see, unless they're done with something like Aztec.
Yes, exactly.
Uh-huh.
Right. So then if we have that, if the answer is no, so if the answer is no, then we say no. Then we have, what do we have? Then we need CKP for non-token transactions.
Mm-hmm.
And we need and we need Aztec type transactions.
Mm-hmm. And
or tokens.
I'm wondering if that's like a short-term requirement, or if it could be yes for now, but no in a couple of years when this stuff is more mature. Because like Aztec is great, but it's not completely ready for prime time yet, I think.
Yeah. So if the so here's the yeah. So here's the question. So let's explore the yes a little bit, right?
Mm-hmm.
I would like to understand the yes a bit more. So yes, what options? So we're, if everything is no, then we're stuck here. If the answer is yes, then can we have what options do we have here? We would have optimistic rollups, right?
You have rollups, although my instinct is that rollups don't provide the scalability needed for something like baseline, and that something with off-chain data might be better because it's more scalable. But rollups are an option.
Optimistic rollups. Yeah. Otherwise, it's just it would just again a question is So what?
You've got optimistic rollups, you've got ZK rollups, and then you've got hybrid things like Arbitrum.
Yeah. But that is really that's a sidechain really.
It's kind of a sidechain, but it falls back to a rollup if anything goes wrong, and it is secured by layer 1. So I don't think of it really as a sidechain. It's sidechain-esque. But because the true sidechain is not secured by layer 1, but I believe Arbitrum is.
Right. So, but the real challenge. So let's actually let's do this here. Let's talk here about tokens and non-token transactions.
Mm-hmm.
I would like to break that out. I think that's better.
Yeah, good point. Yeah, because if you're talking about pure token transactions, then you have more options like fuel.
Right. So let's talk about the non-token transactions first. So what do we have? We could have this. And then we could also have, what else could we have? Yeah, we could have, well, I mean, if you can see the data, why use ZK rollups, right?
True.
Except for the tokens, maybe, right? So it's a question of
I mean,
it's really like sidechain type things.
You don't have the exit delay problem with ZK rollups.
Yes, that's very true, right? So here it's like here you need really here you need ZK rollups.
For tokens?
Yeah.
If they're fungible tokens, so are the tokens fungible or not fungible? I guess they're not fungible, right?
Depends. They could be fungible.
If you're talking about fungible tokens, then you have options like Fuel, which is a rollup, but it's more scalable than something like Optimism. They use UTXOs.
Okay, yes. If you use UTXO, but you have the data availability problem then still.
No, they post everything on layer 1, but they use UTXOs internally. So they get more throughput than.
But don't you? Like, yeah, but if you use UTXO, then it's like Bitcoin, right? So you just need to.
Within the layer 2, it is, but it's still a rollup in that all the transaction data is posted to layer 1.
Right, but you need to be able to follow the UTX. So you need to from layer 1 block to layer 1 block where the rollup is written in. I need to be able to reconstruct. I have to be able to go back to the Genesis block.
Yeah, I think they have some way of doing that. I'm not sure how it works.
Okay. So okay, so let's just say ZK, and then the alternate. Another one is like UTXO
rollup.
Okay, why is this not?
Okay. So, now the question is, so that really, so what we discussed before we came is like, you could do just ZK rollups and then decide whether you want to post the data on chain or just keep everything off chain and just post an anchor.
Yeah, I like having, you're talking about Volition or what do they call it? ZK Sync, ZK Porter, right? I think they're both.
Yeah,
something like that.
ZK, yeah. So ZK Sync posts everything, all
Yep.
the transactions, but there is the option if you use the porter, then you can you don't have to post all the data. You just have that in a you just have that off chain in the network on a shard, and then you just anchor that on L1.
Yeah, I think that's pretty interesting because it's way more scalable than a standard rollup, and data availability doesn't seem like an unsolvable problem in the baseline space.
Yeah, I think that there's an interesting option of doing. Let me see what. Hold on, no, that's not what I wanted. It's like.
I mean, one option is any company that is concerned about data availability can run their own node and store all the data.
Yes, so it's a hybrid. It's a ZK. It's a really ZK rollup hybrid where you have.
I think the term that Starkware gave for this is volition.
Yeah, volition. Okay.
I don't know if everybody's buying into that name, but that's what.
Yeah, whatever. It's like it's a house. So this is this is like ZK roll up on chain, posted on chain for tokens, and then the other one here is CK rollups, but only anchor hash on
Validium
chain.
is what you mean, right?
Huh?
Validium is basically what that is, right? Yeah.
Yeah, or yeah, it's you just keep the block gets stored rather than the block gets stored off chain, and you have a pointer.
Yeah, just the hash,
pointing
and
to
then
that
the
to the
data's off
hash.
chain. Yeah, right.
Yeah, and the data is off chain. Otherwise, it's just like ZK Sync or any other ZK rollup where you just post the entire thing on chain.
Right.
So this would be like, and this is really for tokens and this is like,
right.
This is a hash on chain for non-token transactions.
So I would think that if that layer 2 solution only allows a single operator to run the layer 2 and to store the data, then that would be a problem. But if anybody who wants to can participate in storing the data, then that might be a pretty good solution.
Yeah. So this is around data availability here. Now we're talking about data availability. And not and for here, right? For here, for this one here. So this requires, there are two options, right? So you have network, storage operators.
Mm-hmm.
Not
Storage
necessarily
operators,
process.
and they could be more than storage operators. They could be validators, or well,
Yeah.
actually, in ZK maybe not, because you have to have a prover, and only one prover is going to be running. But
Yeah, I think this is more like IPFS type thing.
yeah. So like Arbitrum is an example. So in Arbitrum, you can have any number of I forget what term they use, but operators essentially, and any operator can participate in validating and mining blocks and also making the data available.
Yeah. So this
So the
is
company that's concerned about that can just run their own node, and then they don't have to worry.
right. So it's at minimum is a storage operator, could be could be full validator.
Right.
Validator, validator or full operator. Right, which you I mean you need a validator here too anyway.
Yeah.
Right. I mean you post it and then someone needs to validate the block.
Of course. Yeah.
Right.
And generate the proof. And generate a proof.
No, the proof is done by the operator. No, it's it's like when you the operator posts the block with the proofs, and then someone needs to finalize the block by checking the proof, by calling the validation function.
Isn't that done on layer 1 by the smart contract on layer 1?
No, that's a yes, but someone else needs to call it. So if no one calls it,
right.
Then it gets rolled back.
Right. It's got to be called
out. Right. So you have to call some third party needs to call the validation method in your rollup contract.
Right. I mean, it could be the same person who's generating the proofs, but it doesn't have to be.
It doesn't have to be. No. It's just someone needs to call it within a certain number of blocks. Otherwise, that block is going to get rolled back. And you can submit multiple blocks, right? So there's a fail safe in there that, you know, if you have more than, I don't know, 10 or 12 unconfirmed blocks, then you're starting to roll back. Right? Then you're rolling the old ones. You're taking the old ones out and then, you know, updating the new ones. So you're rolling it back from the end. The oldest ones get kicked out.
Yeah.
Right. At least that's how ZK sync works. And I'm sure loopring too. So yeah. So that's that. But I think I like that concept of because it preserves privacy.
Yes.
Right. And the and so the key question is, so there's obviously here for tokens, there is one thing though, this is not 100% anonymous, right? That's clear, right?
Right. I mean, yeah, definitely. It's even with an off-chain data, it's not 100% anonymous, but it's more anonymous.
Yeah. So, but it's not fully anonymous, but can be private.
Yes.
Right, because you have right. So this is you know you can for example you can and that really depends on the mechanics of the tokenization. Right. So for example, if a if your user, you know, tells the operator, okay, tokenize this invoice and make this Ethereum address the owner, right? Then there is a priori no connection even between and you know, between anything in the baseline. So nothing. There's no correlatability directly of identities, right? So can be private, and that is, wait a second, that is dependent on, depends on level of privacy. See, depends on tokenization process.
So that's a good one. But I think we have sort of like a leading candidate, right? Because you can because you can get like pretty high throughput with CK rollups, even with generalized ones already.
Yeah. Well, if you're talking about ZK rollups with on-chain data, I mean, the big asterisk next to the numbers that they always publish is that, let's say they assume that they say you can get 3,000 transactions per second. That's assuming that they're utilizing 100% of layer 1 capacity. So that's
well, that's 10 trans. That's, well, it depends on if you, so with Ethereum, right? If you at a 15-second block time and 300 TPS, you can put 4,500 transactions in a block.
yeah, we're getting about 30 or 40 transactions per second, right?
Yeah, so no, like 300.
The rollup
does about 300.
Yeah, 300, or I've heard even higher numbers like
Yeah.
3,000. But let's say it's between 300 and 3,000, 10x to 100x. But that's assuming that you're using all of layer 1 capacity, which is totally unrealistic. If you only have 5% of layer 1 capacity, then you're only getting 5% of that on layer 2 on the rollup.
But you're because yeah, so the gas cost for, but it's like 2.2 megabytes of, so 4,500 transactions, right? In a block is about 2.2 megabytes, and that's less than the block gas limit, right?
I think block sizes are currently running around 50 kilobytes, although they can be larger if they're consisting of mostly rollup data.
Yeah, because it's just call data.
Call data,
it's not
right?
Transaction, right? So it's all call data.
Well, it's 2 gas per. Is it 2 gas per byte?
Yeah.
2 gas per byte. No,
So
it's more than that. It's 16 gas per byte.
16 gas per byte.
Yeah, it's 16 gas per byte.
Then it's
So it's about a megabyte, I think.
Yeah.
Yeah. Okay.
Yeah, it's about a megabyte. So that's about half. So it's about 2,200 transactions in a block.
Right, but that's assuming that you're using
up the entire block.
You're the only thing on layer 1, which is not realistic.
Right, that's true. Well, it depends on if you pay enough.
Yeah. Nobody's going to be very happy with baseline if they take up all of layer 1. But the nice thing about the off-chain data stuff is it scales exponentially, so you can run many side chains or plasma chains or Arbitrum chains or Validium chains as you want, and run them in parallel, and they don't take up all of layer 1. And you can, so it's much higher scalability if you run them multiple chains in parallel.
Yeah, it's really just tokenization transaction that where you need the data on chain.
Right.
So literally, you can say everything is all documents that are not slated to be tokenized can be done all.
Actually, do they even need to be on layer 1 so they would need to be on layer 1 if they're going to interact with DeFi or something that's not baseline. But if it's just doing baseline stuff to other baseline stuff, do they even need to be on layer 1?
You only need an anchor hash.
Yeah. So they could all the tokens could stay on layer 2 unless they need to interact with something that's outside of the baseline ecosystem.
Yeah, you could, yeah, if you could do it. Yeah, you could totally create a token that only lives on in baseline, in the baseline, in the baseline ecosystem. But then you need to agree upon which proof system you're using.
Which layer 2? Yeah.
Right. So exactly which layer 2. So that's an interesting. Yeah. So that's actually a point here. Let me add that here. Running out of space. That's a good sign. So that is really could be actually we can put that here, and we could say that could create only baseline token not on L1 and only usable in
Mm-hmm.
Right, and that point you're just anchoring the fact that it exists on
layer 1.
On layer 1.
Yeah. Could create only the third word should be only, right?
Could create in baseline token. A baseline token.
Okay.
Not on L1 and only usable in baseline ecosystem.
Yes.
Right.
Yeah, and like maybe there could even be sort of a single baseline layer 2 that all of the baseline tokens live on that everybody can agree on.
Yeah, so that would probably require agreement on proof system. ZK are used, or we have would live on sidechain, right?
Sidechain or some other, I mean, like even a Validium type thing, perhaps.
Yeah. So I'm because it's enterprise. I'm saying like Onyx.
I'm not familiar with Onyx.
Onyx. What I'm saying. That's sorry. That's
Arbitrum?
No. I'm sorry. This is not. This is JPM coin.
Oh. Okay.
Right. So because you're talking about enterprise world.
Yeah.
Right. And you're not talking DeFi anymore.
That's true.
Right. So it becomes a real question. So but that's already that's already really good. But that's so yeah, and you could actually do both. Right. So you could have tokens that are ZKP based and tokens that are just then living on a side chain.
That's true. Mm-hmm.
Right.
You wouldn't want it to be too fragmented, but you could have a couple.
No, but it really depends on what you want to use. So if you, let's say you want to have a stable coin on like, you want to have JP Morgan coin and you want to have JP Morgan coin, right? And then you're putting up collateral to get JP Morgan coin.
Oh, okay, yeah.
And that could be baseline, right? Based on a baseline token.
That's true, yeah.
Right. So, or it could be, and then you can wrap the baseline. You can issue the baseline token there, and then you can exchange it for JP Morgan coin.
Mm-hmm.
Right.
Yeah.
So that could be a viable enterprise token ecosystem there.
Mm-hmm.
So that's great.
We have, okay. Shall we take a 15-minute break? I've neither eaten nor gone to the bathroom in like 4 hours or something like that. So you guys can continue on, and again, you can continue to fill in this document, because it's the link is available, and I'm just going to stop sharing and put myself on mute, and I'll be back in like at 4:15, at 4:30 Eastern, 1:30 Pacific.
Okay, I've got another meeting coming up, so I may be in or out, but
okay,
this is great. Cool.
No,
thanks.
this is great. Oh yeah, cheers. Bye.
Yeah, okay, thank you. Bye.
I'll be back. 15 minutes.
Okay, bye-bye.
Hi, Andreas. Andreas. Hi.
Hey guys.
It would help if I put my thing in. My earpiece. It's like, why is he so faint? Hold on, let me go back. A second. Oh, too many tabs. All right. The other question that we had, I think we've beaten that to death, is determinism versus parallelism. How to ensure correct state transitions in a parallel processing environment. And we had started to discuss this a little bit earlier.
Yeah, so you just have to avoid parallelizing transactions between a given set of entities, right? Or between any pair of entities.
Yeah, so we have the VSM.
What's VSM?
Mempool, virtual state machine.
Oh, okay.
Storage. I think that's not really that big of a deal here. So I think, do we need to worry about anything in particular? Let's start with I think there's determinism is really not relevant for the middleware piece because you're just, I mean, it's relevant in terms of message completeness and everything, but that is not something that we need to worry about.
Mm-hmm.
That's sort of like, I think this is really on the messaging side. Messaging, and that's really, here it's really the, message protocol.
Mm-hmm.
It's to ensure proper sequencing completeness. Right, I think that's the key here. I'm using like something like Kafka or RabbitMQ or something like that.
Mm-hmm.
All right, so you have to have you have to have, message numbering and so forth, but those are like all solved for problems. The question is, I think there's nothing on the interfaces and application side. This is really an A in terms of determinism. It's really here on the processing side. Is there anything that we need to worry about in the mempool, right?
Well, do those things need to be considered separately, or can that whole layer 2 instance be thought of as a unit and not be broken down further?
I think it's helpful to break it down further to really identify where we need to worry about determinism versus parallelism.
Okay, mempool
right.
seems like the main place, right?
Yes. It's two places. So one here is what do we? So we need. So the question is, do we need anything? Do we need deterministic deterministic UUIDs, right?
For each
Or
transaction.
yeah, or UIDs, yeah. Per transaction, right?
Then who assigns those?
Right. So I think there's so one option would be so we really need to distinguish. Actually, we need to distinguish here two cases, right? One case is if you have a network.
Yeah, versus single operator.
Versus single operator, right? So I think so from a single, I think the single operator is easier, right? Because you don't need to synchronize anything.
Do they need to be both deterministic and predictable, or just deterministic?
And what do you mean with predictable?
Well, like, do you need to know that transaction A will be processed before transaction B, or do you just need to know that nobody will be able to mess with your order?
So no, so you need an ordering, and within that ordering, you also need to ensure that A happens before B.
Okay, so predictability.
Predictability. So you need something like a nonce.
Yep.
So so I think for the mempool, you only need ordering.
Mm-hmm.
Not, I think or question is, do you want to put that? I think you just need ordering. The VSM will then grab a batch and then process. So here's an interesting question, right? If you care about A before B, right? Mm-hmm. Do you need to worry about latency issues that could sort of like make transaction B that should happen after A come into the mempool before A? And then I'm grabbing B, not knowing A, and then I fail B because the nonce is not right.
That sounds difficult unless if you don't have a single operator.
Right. So do we need do we need a workflow identifier?
Do
you know what I mean?
Workflow identifier.
An ID for a workflow.
That all the steps are. Oh, okay. So all the steps are part of the same workflow.
Yes.
And across workflows, you don't really care about ordering.
Right. I don't care about. Yeah. I don't care about order.
Mm-hmm. That might make sense.
So, do we need? So I think the answer to that is yes.
Sounds like it.
Saying the answer to that is yes, because we need to preserve the logical ordering per workflow.
Mm-hmm. Is there any situation where you might care about ordering cross workflows if the workflows are between the same entities? Like purchase order A should come before purchase order B?
Well, that is the, yeah, for sure. Because that is implied by, so we need, so that is why we need really what we need so the is here is we need a nonce. You need unique counter, right?
Yeah.
Counter per process, per workflow.
Per workflow, yeah.
Right, workflow.
So workflows need to be unique, and then the steps within a workflow need to be uniquely ordered.
Uh-huh.
Okay, yeah.
Right, because otherwise I don't see how else you can.
Is it sufficient to just have one ordering, or do there need to be two levers of ordering?
What do you mean, two layers of
Well, you've got ordering of workflows and then ordering of steps within a workflow. Could that be collapsed into one layer of ordering?
So I think you have, so you're thinking of, I think each document kicks off its own workflow. Oh, what you need a workflow, and you need a workflow instance.
Hmm.
Do you know what I mean? So you have an MSA, let's say that has ID 1, and then you have then you generate a purchase order off of that MSA, and that has ID 1.
Okay.
Right. So it's and that is sort of like purchase. That's sort of like in the procure to pay workflow, which has ID 1, 2. Right. But then you need to identify which are the if you have different documents, different purchase orders, they're different.
Yeah. Which is the workflow? Is workflow the second layer?
So there's a workflow ID, and then there's an instance of that workflow, because the workflow is sort of like you need the MSA, then you have to have an order, then you have to have an order acknowledgement, then you have to have a shipping notice, then you have to have a receipt.
Oh, okay. So workflow is like a template or a list of steps.
Exactly.
Okay.
Right. So you need and then for that particular workflow you have an instance, right? So it's like 1, 2, 3 -1, 1, 2, 3 -2.
Okay. And then you have steps.
Right. So actually here we need to have the per workflow instance, which means we need actually we need to all we also need to have we need to have a workflow instance ID.
Yeah, and on the left you need a workflow unique counter per workflow instance.
I'm sorry, what?
On the left side, you have unique counter per workflow instance, right?
Yeah.
That's per
Yes.
instance. Yeah.
Yes.
So you still have two layers of ordering, though. You have workflow instance ordering, and then you have transaction or workflow step ordering within that. Is there any way to collapse that into one ordering?
I don't think so, because again, it becomes so. So you need to apply. So it's important. So the instance ordering is also important,
Okay.
right? Because if you have kicked off instance 1 and then instance 2, right? It's important to know that instance 1 was really supposed to be kicked off as instance 1, not as instance 2.
Okay.
So we have a question: is who assigns those? Right. So really the one of the key question is who assigns the who assigns the identifiers? Who assigns identifiers? Well, that's the key question here. Here's this one. So yeah, so who assigns identifiers? Good question.
The single operator, you can have the operator generate them, I suppose, but if it's a network, it's still difficult.
You know what? I would have the user assign, except for the nonce.
Mm-hmm.
No, even the oh, you know what? The user should just generate that, right? Because the nonce is in Ethereum is also user generated.
Okay, just a random number.
No, not a random number. It's like a counter.
Oh, the counter. Okay.
Right. So the nonce in the Ethereum account starts with 0.
Yeah.
Right. So and the validity check is that you're submitting a transaction with a nonce 1.
Yeah.
And then 2. And if you're submitting another transaction with a nonce 1, that transaction gets rejected.
Right.
So the client doesn't assign the nonces. It just validates the integrity or the consistency.
So if two parties are transacting, can you assume that they both know what the next nonce should be? I guess they should, right?
Yes. So really, here is the hold on. It's not. I think the workflow initiator should assign the identifiers.
Mm-hmm.
Just to jump in, isn't that already guaranteed by having a workflow instance, or must be incorporated there?
You can have multiple steps in a workflow instance.
Yeah, sure.
Right. So in each workflow, you need a counter.
Yeah, but that if workflow has a meaning, then that means in the instance of the workflow, all the steps are inherited already.
What do you mean?
On the right hand, we need to preserve the logical ordering per workflow instance. So, so I have instance 0 or 1 of the workflow.
Mm-hmm.
The workflow itself isn't nothing arbitrary, but is a defined logic of steps, isn't it?
Yeah. So the workflow is sort of like is a template, right?
Yeah, and within the template there is defined shipping can't happen before ordering, for example.
Correct.
Placing an order. So the identified steps or the steps which need to be executed only after A is already identified in the workflow. Or what do you mean? Who assigns identifiers?
So, so what identifiers do we have? We have the identifier of the workflow itself. That's a unique identifier, right?
Yeah, that's like a smart contract.
Yeah, whatever. It's a string. It's a unique string.
Yeah,
it's a GUID.
Yeah.
And then derived from that, there's an instance of that workflow.
Yeah.
And so then there are so for example, there's a base document, there's a base state, right? And that base state for 2 different instances could be different. Right. So if I have price discounts based on volume that I've ordered, I have different pricing on 2 POs, right? So it's important which PO comes first, right? So what's important?
Yeah.
Right. So
got it. Yeah.
Right. And then within the instance itself, I could have multiple shipping notices.
Yeah.
Right. Or I could have multiple receipts, and I can have returns and things like that. So, but they happen within one instance. So I need a counter of those because the number of steps is not necessarily fixed, right? Is these steps occur, but I have no constraint necessarily on how many times they can occur, right? So I need, for each instance, I need a deterministic counter.
Yes, sure. Yeah, got it. Right. Yeah.
Right. Identifiers, nonsense. Right. So and especially if they share a common state. So so here's a question. How are we going to represent 2 instances that are based off of a particular document that has the same document, 2 different states? So that's the example of, PO1, PO2. PO1 assumes a certain state of the MSA, and PO2 also assumes a certain state of the MSA. So now we can make a hard requirement and say that that only when you submit your PO, you need to read the latest state off of baseline, because then you know exactly what's the right nonce, which is the work, for the which instance, and what's the right state of a document, because the underlying document of a workflow could have changed state, right? The MSA could have changed state because of the commercial transactions that have happened.
Can you be sure that the state won't change between the time you read it and the time you submit your transaction?
That's exactly that is the problem, right? Which I mean, you can I mean, you could solve it by saying by introducing a bottleneck and saying every transaction needs to come from the same account, from the same identity, and that identity is responsible for ordering.
Mm-hmm.
Right? So it's like it needs to make the consistency check and say, well, no, this PO1 actually really happened before PO2. So you need to process PO1 before PO2.
Hmm. Is that something that could be negotiated between the parties rather than having a third party arbitrate it?
No, it's not arbitrated. It's if you instantiate the workflow, you're sort of like setting the I mean, you agree on the rules and everything and on the initial state.
Mm-hmm.
I'm just thinking, so what? So how can we? So we can just do a hard, we can just do a hard a hard fail in the VSM if, for example, you submit 2 transactions with the same nonce.
Mm-hmm.
And then you're just picking the one that has the earlier timestamp as the or the one that's processed first, whether that's right or wrong.
Yeah.
Right. Because you have advanced the state deterministically, right? Now the interesting thing is if you're but let's stick with that example of PO1 and PO2 where the pricing is dependent on certain things. So if you know about the state of the MSA, then you're applying the right discounts based on the state. That means you need to assume that PO1 has happened already. If you submit the ones with the wrong pricing, right? So for example, you have you have PO1 and PO2, and both are submitted assuming that no discount has been hit yet, right? And then they're processed one after the other, right? And at that point, it really doesn't matter whether one happens before 2, because one will have the correct pricing and the other one will not, because discounts kick in, right? At that point, you would say, no, sorry, that PO is wrong because you haven't applied the right discounts, right? So one would be rejected and say, no, you gotta
yeah,
gotta redo, right? Mm-hmm. So it would be rejected because both have assumed the same state.
Mm-hmm.
Right, of the underlying document from which they derive, and then it's just
so it gets retried.
Yeah, so then it's a retry. So it would actually be rejected for 2 reasons, right? And you have to list all of them. Number 1 would be would be the nonce, and the other one would be the state validation.
Mm-hmm.
Right? Even though you could just say, you know what? Just thinking. Yeah, it really doesn't it really doesn't matter. So if both have nonce 3, let's say it's 3, and both have the same assumption, so one will be processed successfully, and the second one has 2 failure sources. One is the nonce, right, because it should be 4 instead of 3. And the other one is because now the state has changed, and there's no and the state variables for that given into the program no longer match. They're wrong. So that is that's fine. The other failure is what other, do we have another scenario where if you have 1 and 2 and 2 depends on the state of 1, but 2 comes in, then you would reject it because the nonce is wrong, because you submitted it with 4, but you're expecting 3, right? And then you're set, you skip 1, so you should retry. And otherwise, I think that's fine.
Mm-hmm.
So if you know the workflow ID, if you know the workflow instance, and you have a nonce, then that's fine.
Sounds like it.
Okay.
So what you need to submit really here is okay, yeah, I think that's it, and it's all assigned by the identity that starts it, that kicks it off, because everything else is then passed on from party A to party B. So then party B knows exactly what the workflow ID is, what the workflow instance is, and what the nonce is.
Mm-hmm. So the operator doesn't have to do anything special here.
No, the operator only has to check the operator only needs to check the consistency of or the validity of the workflow ID, the workflow instance ID, and the nonce.
Does it even need to know about those things? Like, does this need to be a customized layer 2 that understands baseline, or can it be, like out of the box, optimism, arbitrum, zk, whatever, that without customizing it to understand the baseline protocol?
So I think it does not need to know the workflow ID, but it needs to know the workflow the workflow instance. So it needs to have an account, because that's the state, right? So you need the state somewhere, right? So and each instance is represented by a state. Right? So you need the concept of state within your operator somewhere, right? And that's most easily done, and is currently done in, I think, in any layer 2 with through an account.
An account or a smart contract that's deployed on it.
Well, the account is off-chain.
Yeah, right. Well, so I mean, an account, can an account have an arbitrary amount of state associated with it?
No, 1.
Okay.
So each workflow instance will be its own account.
Ah. Okay.
Right, because and once it's complete, right?
how much state do you need to store per workflow instance?
Just what the current
Just
what
the
the
nonce.
current.
Okay.
No. It's just like with Ethereum, right? So Ethereum has the world state is the hash of the account.
Yeah.
Right? That contributes to the so and the account of a smart contract has two additional fields to it, right? It has the storage root hash, and it has the contract hash.
Mm-hmm.
Right? So similar here, you would have the contract hash of the contract that underlies the processing, and then you have the actual storage state, the actual state of the document, right? Or of the sequence of documents, right? And that way you're and then you hash the whole thing, and that becomes sort of like your hash that goes into the into the overall state root, into the overall state Merkle tree.
Okay, so it sounds like you could do this on an out-of-the-box layer 2 that supports general computation.
Yeah, you need a more customized account structure. So let me show you something. Where do I have that here? Load, come on. So you would need so like for ZK Sync, you need something like this. It's based on ZK Sync. So there are two layers of and this is so you would need sort of like the pub key, so you can have multiple owners. So each owner, each one has their own account. Right, so there are the owner accounts; those are the individuals, and then you have the account. So that's the first layer of the Merkle tree. That's like the balance in the balance leaves in the for ZK Sync, and then you have the actual account. Right, and that has a slightly different structure, but it has an owner hash, number of owners, conditions, how many owners need to sign off. In nones, you have a balance for a specific, if that thing represents a specific tokenization, and here you have the account state root, which consists of all the data aggregated up from the actually it's just the latest it's just the state root for all the transactions that happened off chain on it. That's it. And that is then goes as a proof, as an element into the overall Merkle tree that has the state root that is then used for that's a public input data into your ZK proof. Right. Yeah, so it's very similar to like a ZK Sync Merkle tree structure, but it's not quite the same. It needs some modifications. So you can't do it directly out of the box. It's just not possible.
Not a huge change, but it is an important change.
Yes, it's an important change. It's not terrible, but it's an important change.
Yeah. Okay.
right? Because this allows you, it's like this allows you to then, have, so if this is a workflow instance, right, then you can see how this evolves, and we can add additional, so like the account ID could be the hash of the whole thing, or it could be the workflow instance ID, right?
Okay.
Okay.
Cool. I've got a another meeting I'm gonna have to jump out for, but this is exciting to see.
Cool.
All right. Good luck.
All right.
See you.
Cheers. Jörg, ich spring mal schnell rüber zum Tokenization und guck mal, wie es da läuft.
Ja, Andreas, lass mal. Ich habe jetzt derartig viel gelernt. Das war total klasse.
Ja, super. Nee, ich komme auf jeden Fall wieder. Also
Nein,
geht morgen auch weiter.
Eben, lass es uns morgen weitermachen. Es ist schon Viertel nach, es ist fast 11:30 hier.
Ja, nee, lass du mal. Wir machen das morgen. Wir machen das morgen weiter.
Das ist, man lernt mehr als bei allen anderen. So, lass uns das morgen weitermachen.
Alles klar.
Ich gehe jetzt raus. War klasse, absolut klasse. Nochmal, kann ich die Slides, kann man die irgendwo einsehen? Weil das ist alles ein bisschen klein.
Ja, die sind, du kannst dir das alles angucken. Die Links sind alle in dem Instructions-Dokument drin.
Alles
alle
klar.
Links für all das hier. Ist alles da.
Super, klasse. Sehr schön.
Klar?
Nochmal danke. War gut. War echt
kein Thema.
War klasse. Ja,
super.
Bis demnächst. Ne? Bis morgen.
Bis
Ciao.
demnächst. Ne? Tschüss.
Ciao.
All right. So I think we had finished. We're still on determinism versus parallelism.
Oh, okay.
I think we got a lot of that hashed out. I think from a so from a virtual state machine point of view, and again, hold on, what do we have here? David Youngblood, excellent. Hey, David, welcome.
Hey, what's up? I'm multitasking in groups here.
I'm sorry, you were there was some background noise on your side.
I apologize for the background noise. I'm multitasking in groups and sessions here, trying to just drink from the fire hose here.
Oh, okay, cool. Welcome. We're picking up where we left off yesterday. We're discussing determinism versus parallelism, and when you can hop, as you can see here, there's a draw.io file which is in the instructions Google Doc, and you can just click on that and then hop in here and then see what has been done, what has been discussed, and we're continuing right now just on determinism versus parallelism. So we were discussing yesterday what that means for a single operator. Oh, we still have to we have to talk about that for network. Tas, I think that's
oh, network. Okay. I couldn't find the link to the diagrams.net in the instructions doc.
It is right. It is right here.
Oh, okay.
Actually, I was trying to click it, and I got a.
You need to open it up.
Yeah, I tried to open it, and it updated the title to the link.
That just opens a Google Doc with the high-level stack architecture.
Yeah, you just need to do that, and then you need to click on open with,
Oh, diagrams. Okay, got it.
and then open with, and then do draw.io
Got it.
or diagrams
Got it.
.net. Wait, wrong one. Right one.
Oh, I don't have access.
Huh?
Yeah, I had a couple of access issues. I just kept clicking and it reopened a new window. And I was able to get in eventually.
It's error loading file not found. It does not exist or you do not have access.
It should be, it's shared with everyone. Anyone on the internet with this link can add it. So
Huh.
if you click on that, that should be.
Could you paste the link in the chat, in Zoom chat?
Sure. Maybe that helps. Or chat. Come on. There you go.
Okay. No, let's look at the file not found, does not exist or you do not have access. Anyway, not that important. I can see it on your screen.
Okay. That's weird.
Yeah.
Are you going through a VPN by any chance?
No.
Oh, okay. That sometimes does weird things.
Mm-hmm.
So what do we need here? So if we have a network,
Oh, right.
So I mean, everything is still pretty much true here. We need consensus on the UIDs, right?
Yes.
So we need a consensus algo.
Can those be determined by the transaction initiator? Just make up a random UID?
Yeah. They can be they're generated, but you need to agree on that that you don't get some conflicting ones.
Well,
right?
if you make a large random number, it should conflict.
But I mean UID with regard to so this is the we have the workflow instance, right? Has one, you have the workflow instance work step, right?
Okay, the steps need to be sequential.
Yes, yeah. and then not only that, right? You also need the you need the nonce.
Yeah, the steps and the nonces. Okay, shouldn't be random.
Right. They need to be right. So you need to get consensus on that, right? So on this combination. So this is a transaction for this workflow instance step with this nonce. Right? It's just like in Ethereum. Right? Think of you have a batch of transactions and then you need to you're processing them. So so the question is so we need consensus on that. Now we need also, what else do we need? We need oops, no, not that. We need need consensus on the UIDs. So that's really transaction ordering. Right?
Yep.
Okay, so now the question is, do we need consensus on execution, as in Ethereum?
On layer 1?
No. In layer 2. If we have a network of operators.
Oh, on execution of the transaction. Oh, well, yeah. Why wouldn't you?
Well, it depends on what it is, right?
Hmm.
So look at it this way. What if I have, let's say if I have, if someone chooses different types of approver service. Let's say one decides to do Starkware, and the other one, you know, a ZK Stark, and the other one uses a ZK Snark.
Mm-hmm. You would allow that within the same network?
Otherwise you have to so if you say yes, so what happens? Let's just do a
Mm-hmm.
decision thingy here. So and say what happens if it's yes,
Mm-hmm.
right? So and here this is yes. Yes. So what happens then? Then you need to use only one execution framework.
Mm-hmm. Within a
Right?
given network. Yeah.
Right. You know, within a network.
Right.
Right. Because it's like with the EVM, right? It's like you can't have two different EVMs.
Right. Of course.
Right. So if we say, however, if we say, oops. If we say no, then consensus, then operators can use different execution frameworks. E.g. OVM, CK, Snark, or ZK Stark, rollup, Validium, whatever, right?
Mm-hmm. Mm-hmm.
Right. So those are the choices, right? So it's like do we I think within the network you need to agree upon contrast to Ethereum. I think within a network here you need to agree on transaction ordering. If you want to have the freedom to have multiple different execution frameworks.
Oh, right.
Right. Otherwise, you don't necessarily have to. Right. You just dump it in, and then it becomes just like a blockchain, right? So you have one node that does all the operations and then sends it out, and then you just need to validate the proofs. Right, you just validate the proofs, and the other ones validate the proofs, and then agree upon that. Once consensus has been reached, you write it to the chain, the result. Right.
What's up?
Hey. People are showing up. Good. We are currently discussing the question of determinism versus parallelism at the processing layer. So we talked about so this is the mind map. You guys can, so we went through like mempool, and we are now at the stage where we say, yeah, we need a workflow ID. We need a workflow ID. We need a workflow instance ID. we need a workflow instance step ID, and we need a nuts.
Oh, this is so meaty. This has got it. This is definitely taking the cake for meaty, and you've got some good competition on that. How many hours did you do yesterday?
We went from like 1 to
7
5 or something like that.
You were still rocking and rolling at 7. I noticed.
No, I just pinged people if wanted to do.
Okay.
I didn't do anything after that. Yeah.
But that's 4 or 5 hours of live content. That means I've got at 2x. I've got 2.5 hours of work to go back through all that stuff.
Well, there's some, not dead air, but it's like there was sort of like also
Lunch,
a lot of education. No, actually, it was a lot of education talk. I had like 15-minute. There was a 15-minute break in there.
I got some great feedback on it. You're killing it here. So I'm sorry. Just keep going.
No. So right now we discussed sort of like the operating parameters around determinism versus parallelism for a single operator, and now we're at the network, right? So what if we have a network, and now we have said, so what are the trade-offs? So we said, well, if we have all this ordering and nuncing, then we need we need transaction ordering, right? So you need consensus on the order of transactions in a batch, in a block, unless you.
And this is all on the L2.
This is all in the processing layer. So this is sort of like the high level conceptual architecture view that we're looking. We have an interface layer, custom interfaces, API gateway, application logic. Then you have the workflows here, identity, messaging. We talked about messaging yesterday. Then here, processing layer, transaction pool, and then public DLT. Make sense?
Is there a link to this in the notes?
Yes, it's in the instructions page. There is one. You can hop into that, and you can go through all of the stuff that we did yesterday. So we need so the question is, if we need transaction ordering, do we need ordering? Do we need consensus on the execution of transactions? And there are two options, right? So we said yes, but then if you say yes, then you're stuck with one execution framework. So if you're doing ZK, if you're doing Groth 16 ZK snarks, you can only do Groth 16 ZK snarks in that network, right? That's it, right? Because you need to get on consensus on the execution, right? Or you need to have an agreed upon set of one that. So anyway, so you need a proposer, right? So it's not you need a proposer that says these transactions, this is the output. Go verify it and check it, right? So that means that your consensus is strong consistency, which you probably need. Otherwise, you take too long, right? So I think one of the things here is one of the requirements here is that your time to consensus needs to be time to consensus in processing layer needs to be much smaller than to consensus in L1. Does that make sense?
Yes.
For everyone, right?
Yeah, I've been making that point a lot. By the way, diagrams.net has really improved.
It has, yes.
Oh wow, I'm going to use this more.
So so the thing is, if you do not enforce consensus on the transactions, right?
Sounds familiar.
Huh?
I was just saying to John that sounds familiar. We were
Right,
just talking about, do we need consensus, like, you know, in of n or n of n, basically.
Yeah, we were just talking
Anyway.
about this, Andreas, on the other discussion about policies. Like if you want to be able to change the state of an existing record,
Sorry,
and
Andreas.
you have it baselined, how many, you know, can somebody grief that and say, no, I'm not going to confirm that? Or is that even a point? Like, should you be able to have I mean, is that even allowed in baselining? Should you say, and Kyle and I would agree, you know, yes, you do need to be able to do it, but yeah, I mean, you could argue, hey, if you baselined it, you know, make a new record if you want to change it, right?
Yeah, so we need to distinguish. So there are three types of consensus, right? So and let me put this in the maybe in a fabric context. This makes more sense, right? So for baseline transactions, you're talking about the endorsers of a transaction, right? So you have you're endorsing the transaction of a result, right? Of a proof, right? So it's like, oh, this order is correct. Check the proof. Yes. Checkbox that. I sign it. Yes. I accept the order as is. It's correct, right? That's a state transition from order proposed to order accepted. That is one type of consensus. That is that's like having a transaction with multiple signatures on it, right? In a smart contract, right? Where that's a requirement. Then you have the consensus on what is the order of transactions, right? I'm processing 1,000 transactions a second, right? From 500 different entities, right? Is there a particular sequence I need to maintain? There is if you're within a particular workflow instance, right? You need to maintain determinism, so you need to ensure that certain sequences are maintained, but you don't need it for the entire batch. You just need it within a workflow, right? But if you have multiple operators, right, you need to agree upon one is a proposer. It says for this workflow instance, right, there are 3 transactions and this is the sequence, and this is in this sequence they need to be processed. Here you go. Other nodes in the network, this is how you need to do it, and the other nodes say, okay, makes sense, right? Whatever the rules are for that, right? Transaction ordering, the same logic that original node applied to that ordering or not is then applied by the other nodes. So that's a second type of consensus that's possible. The third one is that the nodes agree on the output of the execution, right? The actual proof. So you're doing the 1,000 transactions, you're attaching the proofs, you're sending that block out, that batch out to the other nodes, and the other nodes validate the proofs and then sign that batch. And only then can the proposer anchor that batch on chain, right? So we have 3 types of consensus. So John, what you were talking about was the first type.
Yeah, right on.
Right. So
yeah.
just to keep that sort of like separate. And the question is,
once again, this is, I mean, you could do a whole Coursera course just by grabbing, footage from the live stream saves, because you could take that whole session and package up. We're going to have weeks of work getting all this stuff boxed up into stuff. And yes, I'm actually was busy marking the time of this particular, what you were saying.
So anyway, so the key thing here is we need to distinguish what consensus we're talking about. Right now, Tess and I were talking about, and David, we're talking about the before you guys joined, we were talking about consensus for transaction ordering. and for execution. And we said if it's execution, then the network needs to agree on an execution framework. Otherwise, it would be running like two different versions of the EVM. Right? Those would be two different execution frameworks. Right? Unless you tell the nodes, hey, I did this transaction with this execution framework, this transaction. So this was a ZK Stark, this is a ZK Snark, this is an optimistic rollup, this is whatever. Right? You can do that too, if you want to. That increases the complexity, right? You need then multiple virtual state machines running at the same time, right? Then you need to fork this out into different VMs.
Sounds like in that case you have kind of a layer 2.5 that routes or manages multiple layer 2s beneath it.
Yes, and then brings them together.
Mm-hmm.
Right?
Which is complexity.
Which is complexity, and then you're actually assuming that that there is no cross execution framework dependency.
Mm-hmm.
Right? Is like there's are we am I writing against the same account, against the same state, using different execution frameworks, right? And then I need to maintain the order, right? So then I need to synchronize my VMs.
Oh boy, yeah,
right?
that's a mess.
Right? So, it's like, oh, I cut PO1 that needs to happen before PO2, but I did it with a ZK Snark, and PO2 I did with a ZK Stark.
Oof, yeah, forget it.
Right? So I need to make sure that VM ZK Snark stops, it's actually doable. I actually wrote a paper about that, like 3 years ago, parallelizing, but that was just parallel.
Of course you did.
No, of course I did. No, it was just I wanted to increase I wanted scaling Ethereum at the L1 layer. And you can actually do that if you parallelize the EVM, which you can. But everybody was like, no, this is like, you need too much compute. It's like blah, blah, blah. Anyway, this is only for large operators. I'm like, yeah, so it's cheap, right? So anyway, there is a way to using mutexes on the world state to do that. So, but it's somewhat non-trivial. So that's why I'm saying if we're agreeing on if we require consensus on the execution, then you're stuck with one execution framework without incurring significant complexity
per network. But you could have multiple networks, could you not?
Oh yes. So but if it's one network, you could have multiple networks, right? That's fine, right? So what's the advantage of having a network?
Rent seeking? Oh, you mean something else?
No, I mean, why do I need for baseline? Why do I need a network?
At what layer? I mean, I could use carrier pigeons.
Yeah, exactly. But I mean network, not in terms of messaging, but in terms of execution.
Oh, you mean multiple distributed system of some kind, either a blockchain or something else.
like a side chain.
Well, you don't, right? You could run the L2 if you're talking about the L2 on one server.
Right. So we were just talking about.
I have half a mind to stand something like that up. Yeah, I mean, like as long as it's got basically a droid restraining bolt on it from the mainnet, why not? It's the simplest way to get something going.
All right. So that's why we discussed single operator, right? So the single operator restricts you in terms of the execution frameworks. If you just have a single operator, it becomes more tricky. Because if you're here, right, you have here you need to have consensus. So one node can't do anything nefarious, right? Let's say you want to have like something that is not a ZK proof, right? But you just want to do like regular transaction processing with batching and maintaining consistency through nonces and all that jazz, right? But you know, just like with any other centralized operator, if like LinkedIn chose to alter my messages and you know, I send John a message that says, hey, how are you doing? And LinkedIn changes it to like, screw you, John. They can do that, right? Because they're the single operator. In a network, you can't if you have to have consensus on that, right? It's like, hey, wait, no, he said, how are you, John? And you're sending, screw you, John. That's not right. So with a single operator, you need to have an execution framework that does not allow the operator to be nefarious, except for censoring. So that restricts the execution frameworks you can run on that, on a single operator.
So where does this take us in terms of I've been saying in other sessions, you know, I'm getting antsy to see, you know, bountyable issues that we could say, okay, here's a thing to do right now. Build this. It's a discrete unit of work, and we'll bounty that, right? I'd like to get to the, you know, both at the end of the day, maybe in a triage or a brief postmortem over the weekend, next week, and then going into basically so that not next Monday, but the Monday after that, we can go into the steering committee and vote on which issues are going to get bountied. Where do you, sure, Andreas, where do you see the meaty tidbits here that we can say, hey, go, you know, let's bounty this work so that somebody in December can win a bounty on this?
I think that is so there are two things, right? That we, so the bountyable thing is to build a layer 2 hybrid operating processing module that is sitting on an upgradable smart contract architecture.
Cool. So we just need to specify that with more detail, right?
I wonder what about a diamond pattern?
Yeah, no, I mean that's exactly where you're saying. So you're using, so the upgradable pattern, the recommendation would be using a diamond pattern for the upgrade. There is already a code example for a simple anchoring contract with permissioning and a staking that I actually shared briefly already with like Brian. Yeah. Chamberlain. So it's like that's a super simple one. I've written that for another context, but it was, you know, if you want to anchor a hash that is a URI that points back to something, that's the simplest way to do it. But you need to, that is a standalone, that contract is not upgradable. Now you could say, okay, make that thing upgradable, right? Using a diamond pattern. So that way you have the first anchor. And then the second one would be, you know, that's great, but what if you want to tokenize something? So one of the other things, John, that we worked out was, unless you want to tokenize, you don't need zero knowledge proofs on chain. Absolutely not necessary.
Oh, say more about that. I mean, and I don't mean you. You know, I can go back and watch the game tape there, but I wasn't in the session when you.
Okay, so really quickly. So, you know, maintaining privacy, and we're coming to that again, maintaining privacy would say, okay, we're using some form of ZK, right? And since we want to scale, we use a ZK type rollup, whether that's, you know, from Starkware or Matter Labs or AdStack, doesn't matter, right? But what they are doing, they're writing the entire block on chain. You don't need to do that for baseline. They need to do it in like ZK Sync and what the other guys have, Diversify 2.0, is because they're on-chain, they're representing on-chain assets. So if you want to, let's say you want to finance an invoice, the invoice document itself is baselined, but that doesn't have to be on chain. What has to be on chain is the investment contract that is generated off of the invoice as a baseline document, right? Connected to the invoice. And that is tokenized. And that ZK proof for that state, that needs to be on chain, because that is then transferred into in ERC 777 or ERC 1440 or whatever it is, right? That proof needs to be on chain.
Okay, so I'm not gonna. I will not gall you with claiming that I understood that. So
no, but it's
I
saying
might just need
you need to have the data available on chain that you use for any on chain asset. If you have
okay,
an on chain asset, you need on chain data that proves that the asset is valid.
I might be miscontextualizing. So my head is at I need a permanent tamper-resistant bulletin board to put the proof that you and I have as a consistent record.
So what you do,
I would want that on chain. I don't want that in a server that could be corrupted, right? So
no, what you need is you yourself just need that data, because you have an anchor. So what you need, so the anchor hash, right, is just or you can do anchor hash and a root hash, if you want.
Are we talking about DSA? I mean, we had an old, sort of argument long ago, and Brian will remember this well, back in New York City, about why baseline when you can just do digital signatures. And, for a while we were like, yeah, maybe you don't. And then of course it became obvious. Partly it's, the two generals problem, but it's other things as well.
Right.
But all of it, led back to, this is why you want on the mainnet. So, or on on an always on tamper resistant state machine that.
Right. So what you have there, if you take an anchor hash and you say that, or anchor hash and URI, doesn't really matter, but let's keep it simple. Let's say there's an anchor hash and it's a state root, right? The only thing that you need is any party needs, right, is the Merkle tree of that is the leaves of the Merkle tree of that
right.
state
But
root.
I also need I need to know that Merkle tree hasn't been tampered by. So if we just put it on a server somewhere, if I had that Merkle tree and I tampered with it and you did the same with yours, right?
Yeah, but
who
the
gets to
state
know
root
who's
is
true?
Because the state root is on chain.
Okay, got it.
Right.
We're done.
The state root.
I totally agree with that.
Right. The state
Kyle,
root is on
would you?
chain.
I mean, are you more important that you get it than I do? What's your feeling about that? And Sam as well, and Brian, and people that actually type things on keyboards nowadays and not just talk about stuff like I do nowadays.
Yeah, I mean, I agree. This is, I guess, a continuation of the discussion that we had on the previous session where we kicked it around. Yeah, I agree. Unless you're tokenizing,
right,
you don't need the actual commitment on chain. You can use a roll-up strategy if you really want to anchor it to on chain, or you can also not do that. Really, you basically have a lot more flexibility and a lot more scaling options if you don't, or if you aren't trying to get on the on-ramp of tokenization with your downstream artifacts from the upstream processes.
So you would just change the root. So if the Merkle tree of an off-chain, you update the state. You create a new PO. That Merkle tree state has changed, and the root's going to change on the mainnet, and that's the ultimate arbiter of truth.
Yeah,
and that's all you need. But you do need that, right?
Right. So rather than putting the proof and the public data on chain, you just put the public data on chain from the zero knowledge proof, because you get all the leaves, right, that you need to prove that, my leaf is actually in that Merkle tree, and my leaf in clear speak is this document, right? And you can prove that, right? So that's
what's the public data that goes on changes? So I think I know what you mean.
It's the state root of the Merkle tree.
Yeah, it's okay, right.
Right. So, but you have the state root plus the proof that goes on chain, because you need the public data and the proof
together with a common reference string. That allows
I just got
to verify
reconfused
the
again. I
proof.
thought if you have the proof on chain, that's what we've always been doing. What did I miss?
Yes, no. So what you need public, in order to verify the proof, you need the public data and the common reference string. That's what the verifier contract does, right? The verifier
Yes,
contract
got it.
there's the public data and there's the common reference string, right? So it reads the public data, it has a common reference string, it takes the proof, it does the computation on chain and says, yes, that's true, right? So you don't have to do that.
Right. And then,
Right,
and every party to this activity can go and check the chain to make sure that no
Right.
shenanigans happen.
Right. That's what you need when you have an actual on-chain asset.
Hey, by the way, and this is an aside, Brian and Kyle, is Kyle still in, or did he drop for a second? I think he might have dropped. Remember back in the day, how do I signal to the counterparty if I'm not the initiator, or if I'm the initiator and I've got a counterparty? How are they getting signaled to watch for a specific location on the mainnet to know that everything completed correctly?
Through the messaging.
It's in
It's
the, yeah, so
messaging.
there's a parameter in the message, isn't it?
Yeah, and then you can listen for on-chain events, and that, we talked about that previously. It's like about how this roll-up strategy, or basically if you deviate from, or sorry, not deviate, if you so the current implementation of the shield contract, quote unquote shield contract, with the verifier contract, emits events that can be listened. You can listen to them. So just you need to make sure that you still have those same side effects coming out of whatever your strategy is, like roll up or something else. And if you still have a verifier contract on chain, like that can still happen, but you're just not anchoring the same
Got it.
level of I guess what's the term? Like you don't need as you can throw it in.
You don't have to write that much data on chain.
Right. Yeah. Less data and doesn't cost as much. Right.
Oh my gosh, that's an interesting. We were also talking about how, and pull us back in a second, Andreas. I'm sorry to take you in an orthogonal direction, but I guess that's what the point of this meeting is. We were just talking about how would you know if you got debased, or say we were imagining you've got a base invoice record and you're looking at it in your SAP system or what have you, and it's a different color, which means that it's been baselined, and you mouse over and you got a fancy tooltip that says these are the three counterparties, and one of them looks like they're not in consistency anymore. We were talking about how would you instrument such a thing, and then we went into other things like who gets who has the ball on changing the state of that record, if anyone, and how would you get into that, blah blah blah. But yeah, I suppose, say I was off, I was not live at the time when somebody changed the record and ran something, the root on chain would change, and if I'm subscribed to that, I'm going to see that event, if nothing else, right?
Right. So that's part of your workflow definition steps, right? So let's say you have you need 3 signatures on an order, right?
Yeah, that branch is going to change.
Yeah. So what happens is that every single signature is a state change to the document. So
right. But if I'm looking too far up the tree, it's going to be changing all the time, and I'll get the wrong idea, right? But I've got to be looking at my particular branch.
Right. You're looking at your particular workflow instance. So the instance ID becomes important. You're going to look at the particular instance ID step that the process is based on the template that you agreed upon. And then you look at you can say what's the nuns, what's the how far has the state of the entire process advanced, right? Is there an inconsistency? And you see that because either you get a proof that works or it doesn't, right? So as soon as you get a proof that doesn't work, you get flagged. It's like shit's wrong, right? That's the key thing. That's why every time you get a message, you need to have a proof attached to that you can verify independently against either the contract or whatever is written in your centralized database.
Got it. Is there an existing? I guess the answer is probably no. Certainly at some level, there isn't an L2 that would meet the needs of what we're talking about out of the box, is there?
No.
Yeah.
So,
the other part of it is like, you're talking about the state change, and just going through that scenario is like, you can, if your node is offline, there's an aspect that you may not get those messages with the proofs, and then what? Well, now you need to be able to know what you were expecting and from where, and be able to query and catch up, because then you don't have enough on chain.
It depends on your messaging, right? It's like do you have batching? Do you have a user agent?
It starts to like put requirements on messaging such that you can maintain, like in the scenario, John, you were talking about, where like a user at a GUI can like investigate what's going on, like, because they may see that they're out of consistency, but it may be because maybe nothing's wrong. That's just, I mean, a bit, as data changes, your system's going to shift consistency constantly. As someone updates a record, you're going to look inconsistent until you aren't.
Yeah, in the original design, we had that pending attribute, right? When it was Sam's design, we had the smart contract would actually return pending.
You have two different systems operating, what's on chain and then locally to the source system. And you have to allow for reconciling across the distributed system in some way, and then also deal with failures. If you don't get the message, like, well, how do you replay? Do you recover? Are there ways to ask source providers to give you like backtrack?
It depends on what your messaging
that were dropped on the floor due to any number of things. Just to regain consistency. Otherwise, you quickly become inconsistent and then unrecoverably inconsistent.
Well, it depends on so that really depends on how you define your workflow, right? If your workflow is strictly deterministic, even if it branches, right, on agreed upon fork choice rules, right? I can go left or right depending on certain parameter, right? I either have price X or price Y, right? For example, right? So as long as that workflow is adhered to and is strictly deterministic in each branch, right? As it goes, we're good, right? Because it only advances when the condition is met, right? So if you're what can happen is that and from a messaging point of view, right? Obviously your messaging system has to guarantee high completeness, right? Which means even if I go offline, I need to be able to come back online and pull all the messages that are there for me down
in my inbox, wherever that is. Yeah.
In my inbox, right? So that's a requirement. It can't be that's like boom and it's gone. So I need to have
this is, by the way, where, I mean, there are other things that do this well, I'm sure, and there are.
Kafka
but I was so impressed with
email does it, right? It's like an email server that holds all the shit for you.
Yeah, no, I was impressed with how Corda Flows handles this, and I don't say that lightly. I'm not like in the fan base of Corda, but you got to give them props where they do good work, and it looked Corda Flows kind of does a good job of this in ways that are tricky.
Yeah, but I again, for what you need on the messaging layer, right? Kafka is just perfectly fine. Right?
Yeah. Because, well, no, but they improve on like that. I mean, they can keep because they're serializing to disk and stuff like and they have which again you can do in other things. But I was just impressed.
If you have like there are certain requirements that if you're gonna get hardcore that you if you need 100%, then you need to write every message on disk that is
you can have a poll for a year and not blow it and not have this horrible ugly loop running the whole time, right?
Right, but that is because they're not assuming eventual. So they assume you can be offline for a very, very long time, and the messages need to be preserved. And once you go back online,
you're getting it. The point is,
Scuttlebutt was one of those protocols that supports
Yeah.
that really long-term
Yeah.
durability, and then that archiving aspect of it.
Right. And you know, here's the, you know, but here's the thing. It's like well, in real world scenarios, right? It's like there's if you send an order and that order is not accepted, right? In a reasonable amount of time, you're going to cancel the order.
Yeah, you don't want to have 15 Domino's pizzas showing up at your door, right? Which
right, exactly. So that's what you do, and that's what you build into the into your workflow, that you can cancel that, right? So there's
so Scuttlebutt, Brian's right, it does do that. What Corda Flows does, and weirdly I'm sounding like a shill for Corda. That's not even possible.
I understand.
But
yes.
we'll get Gandalf on. But it struck me that they do it peer to peer, point to point, right? So they're with Scuttlebutt, you're gossiping that around a lot, which kind of breaks our model.
Yeah, it's a hybrid kind of gossip, but you have providers that are
permissioned.
They're not permissioned, but like Samon. Remember what those things are called? I guess it doesn't really matter. There's like certain types
that's right.
of
You
nodes
really
that,
studied this, didn't you?
Certain types of nodes that act as relayers for other folks in the network, right? So you connect to the pubs. Maybe they're called pubs, and you can collect messages from your subscribers because they publish to the pub, and I forget the name of the term. I'm sure you all can read about it.
Yeah, no, it's
there's
like
another
it's
operator in the network that allows for and ensures the durability and the transit guarantees from the subscriber to the publisher.
Yeah, it's yeah. You can do something similar with multiple zookeepers in Kafka, where you're replicating messages across, right? So it's the same thing.
Yep.
If one, hey, I don't know where that subscriber is, I throw it over the wall to you. Do you know where that is? Right? I got this message. I can't deliver it. I don't have the. I know I have to. It's like I have the topic, but I don't have that subscriber. Do you have that subscriber to that topic? That's basically what it is.
Andreas, I just figured out who you are in 90s terms. You are the Bill Joy of this stuff. That's who you are. Yeah, you're not the Steve Jobs, right? You're the Bill Joy, right? You're. I think we should give you a lab of your own in Utah and fully fund it. Wasn't he? Didn't he move it all? He moved his little sun labs all the way out to Provo. Anyway.
But I think here the key thing coming back to that, the as long as you have a messaging system that guarantees high completeness, you're fine. I don't really care which one it is, right? You can use MQP for that as well, right? So it really doesn't matter, as long as you guarantee high completeness. Then you know that you're going to get your stuff, and then you know whether something is. You still have to monitor on each user still has to monitor their system, and their application that is right, their user agent, so to speak, right? And if that's down, then they need to bring that up again. But that's an operational issue on the user side.
I just wonder, and we'll end it after this, but just one thought popped in my mind about like the sort of a lot of what these are not my words, but I recently watched a talk about someone who's looking at blockchain as and these ecosystems as a way of coordinating human behavior. And I wonder, just like as someone who's participating in a workflow, what is my motivation to maintain your messages? If I send it to you and your system's down and then you become inconsistent, that's kind of your problem, right? And how much of the data do I have to retain so that you can have an offline system?
So can you sorry, so like why would you become inconsistent?
I'm an administrator. I go in and either nefariously or by accident or for some reason that we can't contemplate now, I change a record.
Oh, you mean in the ERP?
Yeah.
Yeah. So that's why it's imperative that every message that is sent, where you're the recipient of a work step, carries a proof.
I should think that this is where the real opportunity for organizations like AMQP and NATS and others, because they're generalized messaging, if you have one up, then you are a service to. You're running your session on battery, dude. Did I see that?
It's just my laptop. Yeah. I was running out of battery because I've been running it for so long.
You know what I'm saying? So if I have a NATS, what does NATS call it? A node? If I'm running a node, it's generalized, right? So now I am part of the NATS infrastructure, right? It'd be kind of like running a router, or do I have that conceptually wrong?
Yeah.
So that,
That's right.
Brian, that would be one way to look at, Brian, your point, right? I'm gonna run it up. I'm gonna run it because for the same reason I keep my routers up.
Yeah, but the NATS doesn't. Well, I guess you could make it durable, but it's typically not, as far as I understand it, is a.
Okay, so that is where I had the concept wrong. Yeah. Okay.
So I guess that there's probably some amount wherever it bounces around the network, but eventually somebody drops it. And that's the part where it's like, okay, anyway, we can table the rest of that because that's like a whole in the weeds discussion about deliverability and if that proof never shows up and I don't get it, what do I do then? How do I?
So that's why I actually put in a definition of a circuit breaker. So that's where you're then breaking the circuit. That's where the cancel comes in, right? You're right. So but you need to build that into your workflow. It's not that it's like magically there. You have to have that exit criteria that you can pull at any time, right? Or for each document has its own exit criteria, right? That you can the circuit breaker, which could be like dispute. If dispute, then you can only if both parties agree that it's done, then you can continue processing, right? So then everything goes off band, right? Out of band.
I gotta hop out for a minute. I gotta promote another session starting up, but yeah, it sounds like if there isn't an L2 like this, I mean, Tosh, it seems like a real opportunity for somebody.
Yeah, there is no L2 that meets all the requirements, right?
So somebody can make some money doing that.
So we'll write that down. There's also there's a spreadsheet that has sort of like evaluation criteria for L2s, and we'll need to add a few more to those. There's sort of like a base set in there right now to start with, but they're going to be based on these discussions here. We're going to add more.
Right on. Carry on. I'll see you guys soon.
So I think so we're single operator. So single operator, I think we have beaten that horse. We have beaten that horse to death. So I think there is one key thing on the virtual state machine we should probably talk about for like a second. And this is supporting, comes back to what we had before. Do we want to support supporting multiple execution framework? And here's there's a pro con here, right? And they've kind of, we had that. So what's the pro? There's flexibility in offering. So, but what does it require though? You need to right? Yep. Am I saying this right? If you do that, then each workflow, so each execution framework, so you need to decide which execution framework you want to use for each workflow.
Yeah.
Yeah.
I think that's a requirement. You can't just like switch in between, and that means like if you're build, because otherwise you can't because that requires, if you do ZK snarks, I mean you're like the danger is you're getting like different results. It's just more complex.
Too complex.
Yeah.
Is there an assumption that workflows end too? I mean, there's like, would there be an infinite workflow? Because like, yeah, it's like, if you wanted to switch execution frameworks, you sort of like wait for your workflows to drain, or you set in a rule.
No, you
know.
No, you can run them in, you can run the same workflow in parallel. It just can't be the same instance. So
yeah, no, I write that. Yeah, right. Yeah.
So you cannot have
transition, and you can sunset one and version or run.
Yeah.
Yeah.
Or let me say is that a con here, is you cannot deal with cross framework state dependencies. So what does that mean? That's like, if I have an MSA and I have an MSA embedded in one framework, right? I can't really switch that MSA to another framework without completely shutting down the MSA in the first framework.
Yeah, I wonder if there could be some mechanism to like what we do with tokens, where you, I'm drawing a blank on the term, where you lock up that MSA in one workflow and spawn it in, sorry, one execution framework and spawn it in another one. What do they do that with? What's that term with tokens? Where they do that?
Well, you mean like with wrapped with wrap BTC or stuff like that, where you do a swap from wrapped from what is it, span to signature hash transaction, and then you're on Bitcoin.
Yeah, I'm not saying it would work exactly like that, but conceptually, like, you know, it doesn't. I wonder if you can come up with some kind of way to do that. So it's like, you could have cross framework state dependencies, but you couldn't change once that MSA was in one framework and then wrapped. Then it would be locked.
Yeah. But that means like if you lock that state, right? If you lock that means you end the state evolution in that execution framework.
Yep.
Right. You cannot process anymore.
Right.
Right. So that so that means you cannot deal with cross framework state dependencies. That statement is still true.
Yep, that's right.
Right. So it's like probably give an example.
I think it's an okay constraint. You cannot, if you have a way to mitigate it, it's like, they cannot quote unquote deal. It's like you can deal, but it's just the trade-offs are maybe not ideal.
Yeah, you need to close out, e.g. MSA in one framework.
This is like really way far in the future, but I was imagining just like someone who had existing artifacts. Let's say call them invoice, like because we're talking about invoice tokenization, like in one framework, and there's a great tokenization and exchange for invoiced or tokenized invoices in another framework. Then you basically have a way to port or migrate your invoices from one framework to another, such that you can take advantage of the tokenization and the other kind of thing.
Yeah, but I mean, if your assets are already on chain, you could, that's not a problem, right?
Oh,
I mean, right, because it's like in the end, whether you're using ZK Starks or ZK Snarks for your on-chain data, the proofs for ZK Snarks or ZK Starks really doesn't matter.
Oh, okay.
Right, from a tokenization point of view, it's just metadata that I am embedded in the smart contract. And a pointer to where I can find that metadata, right?
Okay, that makes sense.
Right. So, and then whether it's in 721 or 4040 or 777, it really doesn't matter. Right. As long as it's embedded metadata in that contract that I can in the token contract that I can trace back to my source of truth.
Mm-hmm.
Right. Now, the interesting thing is what happens if that state changes. So I don't know whether that was discussed already in the tokenization working group, but the key thing is like you need to update the token contract if a state changes.
Yeah, I feel
right.
Like so what was said maybe at some point, maybe not in this conference, was that it can't change. That's like that's a
that is absolutely that. But so if you have an asset-backed security, that happens all the time.
Well.
Right,
yeah,
because
I don't know enough to know what.
But I mean that's the point,
Sure.
right? You have a continuous payment. You have a continuous payment flow, and if you have like in a mortgage-backed security, you have defaults, right? So
Sure.
that change. So the contracts upon which your investment contract is based on change all the time, which means the state of your investment contract changes, and that needs to be reflected in the token, at least in terms of maybe not in value, but it's like in the data. Right, and actually the data in the contract determines the value.
Mm-hmm.
Right, so as that changes, you need to reprice it.
Yeah, that makes sense.
Right. So anyway, that's just a so I my sense is that it's like if you as a service provider in a scaling framework, or generally speaking, you want to offer more than one framework, execution framework, but you want to make sure that you don't you keep people neatly in their swim lanes and avoid crossover unless you have to. Right, but that's a provider issue, right? We're just highlighting the pros and cons here. Is there any more determinism versus parallelism
I think with regard to the public DLT, there's nothing. The only thing, hold on, on the VSM here is, or here we have mempool. And here we have storage. So the only thing is, but that's a general problem. What do you deal? How do you deal with like transactions that are on the same document but in different stacks?
Different stacks or different shards? Like if you're running on different shards, then you'd have to make sure that each document is only on one shard, right?
Well, so here's the thing, right? So what if I and I think we discussed this yesterday, right? So what if I haven't, if I'm let's say I'm BMW, right? And I have an MSA with Bosch, right? And Bosch provides me with for my cars, Bosch provides me with the lights. That's one business unit, and it provides me with what is that? The electronics for my transmission. That's another business unit, right? So, but we have the same MSA, blah blah blah, and we have different, different pricing tiers and so forth. So, but it's the same base document, and that state evolves, and both business units do business with BMW, but they're independent of one another. They have different P&Ls. They have all, maybe even different ERP systems or non-synced ERP systems. So how do you deal with a situation where you're dumping a PO in one stack, and let's say the light unit runs a baseline stack for Microsoft, and the electric unit, or the motherboard unit
right.
runs one from Provide. What then? They're referencing the same MSA. Do we then have to like break it apart? It's like you have the MS. Is there so what if there is an indirect state coupling, right? So abstractly, if there is a state coupling between two different stacks that cannot be represented properly, right? It's like would you then have to have a oh yeah, I need to come. So I'll leave you with that question. I have to drop for a few minutes, and I'll be back.
Cool.
Okay. I'll just need to leave for a second. I'll be back like 20-30 minutes. Go back. So yeah, I think we left off. I think we have this here. We're discussing the fact that if you're in two execution frame, if you're writing to the chain, there is no way of knowing. If you have submitted two conflicting transactions into different baseline stacks, there is no way to reconcile that.
Right.
If there's a state dependency. right? I think we should just capture that for posterity as a statement. So if there is a state dependency transactions implementations such as a shared baseline. Stacks. There is no way to ensure consistency of both off-chain and on-chain transactions. I think that's the nut of it.
Makes sense, yeah.
We just need to capture that as a just, you know, we'll do that. I think otherwise I think we're pretty much done with determinism versus parallelism.
Mm-hmm.
Should we talk about data availability versus throughput versus privacy?
Yeah.
That's an interesting one. I think there is, yeah, I think there is so on the, there's nothing, data availability is really, there's on the, it's just on the messaging side, there is a small dependency. That's completeness, right? Message completeness.
Dependent on message data availability or on transaction data availability?
No, it's on that the, why is this?
Wow.
Damn, what's going on? What is going on? Oh, because I must have, why am I, what is this? Okay. So something was going on. I don't understand why this is. Anyway, so if you request data, right?
Mm-hmm.
You need to, if that is sent to you and you're not listening,
mm-hmm.
then somehow those messages need to be, that contain the data, need to be batched somehow.
Mm-hmm. Yeah, but,
right?
but messaging data availability is a separate problem from blockchain
Yes.
data availability, right?
Yeah, exactly. I think that's all, that's the only thing that we need to, but that's a requirement. So
Mm-hmm.
that's like, you know, for example, Scuttlebuck, Kafka.
Scuttlebig.
Huh?
Scuttlebig.
Oh, Scuttlebig, Scuttlebug. But
Scuttlebutt, isn't it? B-U-T-T.
Yes. Huh?
Scuttle B-U-T-T, isn't it?
Scuttlebutt?
Yeah, I believe that's how it's spelled.
What? So it was Scuttlebug. Anyway, doesn't matter.
Which is it actually comes from the name of a water cask. The water cask was called a butt, and the sailors would congregate around it to share gossip.
Yeah. Yeah. Okay. Got it. Scuttlebutt. Kafka. P2P don't really have that, right? Or AMQP. P2P frameworks don't really have that, right?
Well, there are store and forward ones. Isn't Scuttlebutt kind of store and forward?
Yeah. Yeah. It's like libp2p. I think that has that, right?
I don't think that does store and forward if you're offline.
Yeah. Anyway.
Not sure.
Anyway, I think that, but that's the only thing. So what do we need here? We have the mempool. We have the M, and then we have storage. So the problem I think here is really from a, oops, why is this? Why is this? Wait, do I have this like? Ungroup. Okay. I must have had that grouped for some reason. So how do we ensure? So the only way to ensure that user has off-chain data available if they're running a node, right?
Mm-hmm. Yeah, if you're worried about it, you run a node.
Now, but that has an interesting consequence, right?
Mm-hmm.
Oh, so that would be, Now, here's a question. Is that, do you want to run that as master slave or master master? You want to run that as master slave, don't you?
I think most of the ones that have been built are peer-to-peer.
Then master master.
Yeah.
I mean peer-to-peer, but it's like, so here's the thing, right? If you're master master, the replication, which is like peer-to-peer, you can write stuff into that.
Mm-hmm.
Right, but you don't want that as an operator. I mean, you want to give people like they have the data, but they shouldn't be able to like change the data that's then replicated.
Right. It's an append-only database, though, right? So it's like a blockchain, except that the nodes aren't necessarily doing computation; they're just doing the storage.
So, but then that's a requirement. Then we need append-only storage.
Yeah, I think that's how it's envisioned in most of the layer 2s that do this, is that all the layer 2 nodes, like whenever a layer 2 block is produced, all the nodes store that block.
So, in order to not have to rely on a master slave config, but rather master or P2P, the storage needs to be.
So yeah, I would think about it just like Ethereum. Like you can be a miner, in which case you're processing transactions and storing data, or you can just be a node, in which case you're only storing data.
Right. So, but then that there's the other requirement is that you can't, it's like, so that's that, but it's append only, right? But you shouldn't be able to oh, wait a second. You shouldn't be able to write, right? Sort of like a user node user node cannot have write privileges.
If they're not doing block production.
Yeah, but I mean that's not what they're, you know, it's like there's a baseline operator. Yeah, it's like unless they're doing.
Well, if
block,
it's single
block
operator,
production.
yeah. If it's multi-operator, then you could have a whole, you know, peer-to-peer layer 2 blockchain.
Right. Right. So actual processing. Right. So this assumes operator network. Right, which is not really what you, I mean, you know, it's like ideally you just want to have the data replicated. I mean, it's the thing, you know, if they want to censor you, if they don't want to make the data available to you, they just turn off the, you know, they just shut down the port. Right. I mean, there's only so much you can do. But that's sort of like the best thing you can do is to run a storage node, at least.
Yeah. I mean, at least the data you have is not, you're not going to lose.
Right. So, and here, actually, let's talk a little bit about here. Let's talk about let's talk a second about security. And that's really shouldn't be a problem if it's shouldn't be a problem. So should not be a problem if it's read only. If you have permissioned nodes for a single operator and all nodes are read only. The search is dependent.
So in terms of read security, I mean, you could have a private layer 2 network that only certain parties can read from, but I don't know if there's a good reason to do that.
Well, it depends on what data you're storing, right? Right. If you're only storing zero knowledge proofs,
doesn't matter.
Right, and account states, you don't. It doesn't matter, right? So so then really from that's around privacy, right? That's really when we're talking about, that's when we're talking about privacy. Let me pull that up here, and that's really privacy. Let's see, it's really no issue if that is a no issue if ZKPs are used.
You might want to have tokens on layer 2 and keep the token transactions private, but I mean, you can also do that with stuff like Aztec.
Yeah, that's oh yeah. So this is actually we need to do a separation here again between non-token tokenized and you know, it's like we need to do tokens and non-tokens.
So this is more relevant if it's tokens. Then you need if you need then you need balances as ZKPs at minimum. Or
if there's a balance, I mean, if it's a non-fungible token, then you might just want to not know who you're sending it to, who somebody's sending it to.
For non-fungible token that's a token ID, right?
Oh, okay.
Takes a for so
Okay,
it's
yeah.
right. It's which is a token ID, and you're just
private.
shielding that, right?
Okay.
You just keep that private.
Yeah. Okay.
It's either the balance or the token ID, right? So it's that. So, but there is the other thing here is privacy of senders requires senders, receivers, or just owners of owners / participants requires stack type anonymous transactions.
Yeah, I mean, you could keep it on a private layer too, but then it's still going to be visible to anybody that's on that layer too. So it's probably not good enough to do that.
Yeah. So you need a you need a shielded account, right? I think that's right. That's really what you need. That's like shielded account. So, I mean, that is. So how do you? Well, it's just a state update, right? It's just you need to I would have to look into the stack anonymous transaction because it gets a little bit more complicated because a baseline account can have multiple owners.
Oh.
Right. Look at it this way, right? If we said that we have a let's say we have an account that represents a workflow instance, right? As we said. So and then the state's updated, but the entire account is shielded. Then we need to have that means, but multiple entities will have to have access or have to have knowledge of the account content. Right. So that's the thing.
Yeah, I don't know if there's a way to do that with stack.
So it's a requirement.
Yeah.
Right. So it's because you have yeah, you can have an asset that has multiple owners, like a document that has multiple owners that needs to be tokenized. I mean, that's really, it's only relevant for, this is really only relevant if you want to tokenize things. If it's for the bulk of everything, it's not an issue because the usual ZK Stark is perfectly fine.
Yeah, it's down the road.
Yeah, so I don't think that's really
And it's probably doable. It just maybe hasn't been done yet.
Yeah, I mean, and again, it doesn't have to be like super high throughput because you probably will not have, probably if you could do like on the order of like 10 transactions a second, that would be fine.
Really? You think?
Well, I mean, look at it this way. It's like 10 transactions a second is like for an operator. That means if you have 1,000 companies, or let's say, let's make it even larger, 10,000 companies, right? That means that you would have to have 10 companies a second could do a tokenization thing, right? Could tokenize something, 10 a second. That's out of 10,000.
That sounds like a lot, but I mean, if you look at the requirements that John had kind of sketched out for transaction throughput and like how many companies doing how many workflow steps per month, it was something large number of transactions per second, like tens of thousands.
Yes, but
maybe
now we're talking about token transactions.
Yeah,
tokenization.
But I mean, couldn't it be like maybe 10% of total transactions, or maybe a couple percent of total transactions?
How many? Okay, so how many invoices do you think are factorized or financed?
Good question. I have no idea, but probably a minority. Yeah.
I would say so we're talking about 9 billion commercial transactions.
Yeah.
And how many of those are getting financed? I would wager that it's significantly less than 1%.
Yeah, you're probably right.
Right. So if I can get like 10 to 100 transactions a second out of
Maybe
that,
that's enough. Yeah.
That should be enough.
And I would imagine by the time this takes off, the technology will improve.
Yeah. That's it's just can we get more fit? I mean, the thing is, it's like the if you need to shield the inputs, then your input becomes a zero knowledge proof. So if you think of it this way, you need to validate the zero knowledge proof that represents a balance or represents a sender, right? In the circuit. That's why it's so hard. Do you know what I mean? It's like if you think about it from a mechanics point of view. So what does a prover service a circuit do? It checks constraints. Right. So I'm sending a balance. That balance is obscured. Right. So but that needs to fulfill a constraint. Right. So is the balance larger than something, or is the balance larger than 0, but smaller than my balance?
Right.
Right. And then is the so that's a so there you have a range proof, and then you have a proof of ownership. Is this what is the proof of ownership of the account, right? Is a zero knowledge proof. Right. So this is an ownership proof. Right. And then you need to validate that as an input to another proof that you're generating. Right. So you need to validate a zero knowledge proof inside a circuit.
Okay.
Do you know what I mean? So and that becomes really so if it's just validating a hash, right? That hashes match, that's relatively straightforward, right? That's like, you know, it's like signature validation. It's like in a circuit. It's not that hard. But if it's you know, or a balance is just a range proof, right?
Yeah.
And there a range proof is relatively straightforward, right? It's like you're updating that you're using the semi-homomorphic encryption properties of like commitments, right? These are all commitments, right? That are semi-homomorphic, right? So you can do add and subtract.
Yep.
That's why it works with balances, right? So these are you can do that and then that becomes a new output, right? You're doing this in the circuit, right? So you have the two accounts or the input, and then you're adding and subtracting the shielded accounts and the shielded balances, right? Because they're just commitments that are semi-homomorphic with regard to the encryption scheme. So then you can do that you can do in the that you can check in the circuit. It's slow, but it's you can do that. The same thing with ownership. But if with multiple owners, then you're adding more and more constraints, right? Right, because now you also need to check more signatures, right? So it's like the circuit complexity it's doable. It's just the circuit your circuit size gets large.
Yeah.
Right. So I think that's primarily it. Right. I'm just working through the sort of like aloud as I'm thinking about this. So I think that should be doable. And I think that's what you know Walcott and cohorts are currently working on. That they can do that and they actually have done roll-ups for that.
Who's working on that?
Aztec.
Oh, okay.
Right, that's Thomas Walcott something. I forgot.
Yeah.
Yeah, Walcott. Yeah.
Yep.
Walcott, Walcott. Yeah. So that's that. Data available to the privacy and storage. That's really what the then here you need to be able. So if you have here for the VSM, right? It's like really. It's the same thing, right? It has the for storage and it just is the same thing, right? It needs to be able to process that, right? So
yeah.
Right. Right. Otherwise, the security is the same thing, right? If your crypto is shit, you're done, right? I mean, it's right. It's that's fine. Let's talk about on-chain. Really need the we have two things. Let's just
let's just do it storage and just let's just do it here and let's call this privacy. Right, because it's really data availability. So you need again, here you have tokens and non-tokens, right?
Right. The non-tokens are the layer 2 anchors.
Yeah, it's just like yeah, these are just L2 anchor hashes, right? Actual data
or transaction data if you're talking about a rollup.
Yeah. Right, I mean that's a basic statement.
Yeah.
Right, and then so privacy is shielded. Let's see, shielded that way. Right.
Well, because the transactions are done privately in L2.
Yes, they're done privately in L2. That's yeah, right. So it's because right, and then here we have so, but for tokens, obviously, we need
and these are tokens that need to leave the baseline ecosystem.
Yeah. So there you need yeah, you need ZK rollup proofs. Right.
Yeah, I mean, maybe it doesn't have to be ZK rollup proof, but you need some kind of a claim made by the layer 2 that that's a valid.
Well, it needs to be a zero knowledge proof. This doesn't have to be. It's just a ZK proof.
Does that? I mean, if you're using optimistic rollups, well, I guess you still want to use ZK transactions on the rollup. So.
Yeah, because you want to preserve as much privacy as you can.
Right. Okay, yeah, you're right.
Right, so you don't want to reveal anything of the underlying transaction, which you do in an optimistic rollup.
Yeah.
Right, because you're doing well. I mean, there you're doing just the signatures in the rollup.
Right. Okay.
Right, but here you want to do here you want to do more. Right, so security is really based on so it's really L1 security guarantees, right?
Right. Yep.
Or assurances. People
Yeah.
like have.
There's no guarantee.
Right. L1 assurances, and you have here you have is the geographic of anchor hashes. CK proofs. Really, that's what it boils down to. Anchor hashes, signatures.
Oh yeah. Mm-hmm. Yep.
Right. That's
Mm-hmm.
fair enough. Good enough, I would say.
Yep.
Right, and that that's solution dependent, but I think that's right. So anything that is token that needs to leave, you need the stuff on chain. Everything else can be off chain. Data availability is then governed based on here.
Mm-hmm.
So that's good.
Mm-hmm.
So this was so what I also had was to continue working here was
You have a lot of tabs.
why do I have, what is this? No, this is wrong. Wait. That's the wrong one. Yeah, that's what's. So we I think I'll do that later on. I'll collect the requirements out of this here. I have scaling. This might be of more interest to you. These are sort of like scaling evaluation criteria.
Oh, so, yeah, for a given L2 solution. Mm-hmm. Live assumption. Yep.
So this is basically from
the matter from the article that what's his name?
Yeah, Matter.
Labs. Yeah.
From Matter Labs, right?
It's a little slanted towards their stuff, but it's a good start. Yeah.
Well, I mean, it's the question is what's the suggested implementation, right?
Yeah. Yeah.
So and the priority I added.
Okay. Yeah.
Right. So so usability, so exit time, obviously that's important. Time to subjective finality, client-side verification, instant transaction. I mean that's all relevant for like on-chain data, right? So for tokens, I think that's so I think what we need to like tease out is sort of like is the sort of like what we discussed in terms of what we discussed like for data availability and determinism and so forth. So I mean, we can work on that, or we can right now. I mean, that's just like filling it out. But I think maybe what we could do instead, which might be more fruitful, is not the smart contract reference architecture, but wait a second, I had this. Wait, it was. Oh wait. I thought. Did I just click this away? No. Can we do a hackathon use case?
Okay.
Right, for scaling.
Mhm.
Right, so we have a problem statement. And then problem statement. Then we need suggested materials, or technical requirements. That's really what it is.
Yeah.
And then suggested components. Right.
Mm-hmm.
So I think it might be worth just looking at that.
Sure.
Talking about that a little bit. Let's move this up here. So from a problem statement, what do you think would be an interesting one? Should we just focus on like a non-token one, or just or also with a token?
Oh, I don't know. I mean, do you think the tokenization stuff is going to happen in the next year and a half, or is it further out?
Something like will definitely happen, right? So I think maybe we can do two problem statements. Why don't we have the problem statement broken up into two parts, right? Is a non-token piece and a token piece, and say, so it's like the non-token piece is mandatory, the token piece is optional.
Right.
Okay. So so it is what should we do? Invoices?
That's
an easy
that's
one.
the standard one, right? Yeah.
Yeah, doing invoice. Create and finalize invoices between just two participants. Keep it simple. And a sustained rate of what, like 1,000 a second?
Wow, that's a lot of invoices.
Or 300?
Between two participants? Wow, that's
No, I mean, but it's like you take two, but it's like you're between two participants at but like that's, should we do like 100 participant pairs?
Okay, there we go. Yeah.
Or let's do, to make it
1,000.
fun, 1,000.
Right.
Right. If you do 100, then you might as well do 1,000.
Might as well. Yeah.
At a rate of 1 per second.
Okay.
Such that what such that the such that the how about the participant pairs can see, right? Can see the can see their transactions in in a storage medium, right? But cannot see the but the privacy of the other participant pairs is maintained.
Right.
Right. Such that each participant can run a we should call it a baseline storage node, or
sure.
baseline node.
Baseline node, yeah, because it might be processing too.
Run a baseline node. Let's say non-processing.
Okay.
Non-processing, right? You can run a baseline node and see their own transaction, their own invoices.
So that brings up an interesting point. So if you're using a ZK rollup type thing, there's going to be one block producer that's running the prover. How are people going to decide and trust? I mean, they don't really have to trust them. They have to trust them to not go down. Like, how are people going to decide on who gets to be that or run that and be comfortable with them not going down? It's a little more centralized than like an optimistic rollup.
Oh yeah, but you have one, right? You have one operator.
But so if a bunch of companies have to decide who gets to be that one operator, and do I like the person that's running that operator?
No, that you do one. You choose an operator or a set of operators, and they can that's up to them how they want to solve that.
I mean, I'm assuming that thousands of companies might be sharing an operator.
Yeah,
so,
exactly.
It's like just seems like a political problem among those companies, right?
Yes, but this is a technical issue.
Yes, right. Okay, we'll set that aside.
We'll set the governance aside, right?
Yes,
but what we can say is they can see the see their own invoices,
right?
As baseline transactions. It's baseline transactions, and the baseline transactions of the other participants, but those transactions to shield privacy of the other participants. And the baseline documents, baseline invoices. So create and finalize invoices. And anchor the transactions, baseline transactions, with one on-chain transaction.
Yep. Per what? Per second? Per minute?
Per block.
Per what? Per layer one block? Per layer one block?
Yeah. Yeah.
Actually, that may not be. I mean, the layer 2 blocks in ZK rollups are usually like 10 to 30 minutes, I think, right? Because proving time takes a long time.
Yeah. So in addition, yes, but it's like one on-chain transaction. And such that on-chain transaction, such that each participant can run there and see their own invoices and the baseline of the other person, but those need to shield the privacy of the other. And B, any participant can verify and finalize the anchor the baseline transaction. Anchor the baseline transaction. Can finalize the anchored transactions. Right? That's a requirement.
Any participant can finalize them?
Yeah, the verification is then finalization. If they're right, because again, they're non-token transactions.
Yeah. Okay.
Right.
Okay. Yep.
On chain. On L1. We can so that I think that's a good one.
Mm-hmm. Mm-hmm.
And then the second one is using the baselined invoices create how many? So we have at a sustained rate, let's say 1 minute. Using the baseline invoices, create an invoice-backed security token.
Mm-hmm.
Create not an invoice, create invoice-backed security tokens.
Mm-hmm.
Security tokens that comprise at most 1,000 invoices.
Mm-hmm.
Okay, invoice-backed security token. To be create invoice-backed security or investment contracts. That's really contracts that comprise at most 1,000 invoices and are baselined.
Okay.
Baselines as described above for the invoices. And create so we have 1,000, 60,000, it's most 1,000, and create at least 60 security tokens. At least 60 security tokens, right? Because those are 1,000 invoices a second. For 60 seconds, 60,000. At most, 1,000 invoices in one is. That means I have at least 60 security tokens.
So what's the
right?
difference? So what's a invoice-backed contract?
Invoice-backed investment.
Okay.
So
So
this
that's a
is
transaction. Is that a transaction or is that a smart contract?
Yeah, that's a asset-backed security. So every security has an investment contract. Every investment contract is a document. So that investment contract needs to be baselined.
Oh, okay.
Right? So because that's a new workflow.
Okay,
right?
okay. So it's a baseline document.
Yeah.
Okay.
So baselined invoices. Create invoice-backed investment contracts that compress and that are baselined as described above for the invoices, comma, and then create at least 60 security tokens that are anchored 60 security tokens. Oh, yes, that are transferred
201
from their owners to one recipient each with one recipient each. The transfer needs to be anchored with one L1 transaction.
Okay, so their transfers are happening on L2.
Yeah. Needs to be anchored with one L1 transaction such that the new owner can exit with the token from the baseline operator through an L1 transaction.
Yep.
All right, so let me do. So wait a second, where's this thing? No, that's view, sorry. And it is, no, please. View, formula, no, sorry, format. And we need text wrapping, wrap. There you go. We'll make this a little larger. Oops, that was not good. Make this a little larger. And make this a little wider. Make this a little more readable. Oops. Or forget that it needs to be town. Okay. And all right. Okay. So what are our technical requirements? let's talk about so L2. L2, let's do this. So, do we require full anonymity or for the oh, okay, so the invoice invoice baseline transaction need to be private.
Right.
Right. Let's make it the token transactions. Oh, the invoice. Indices and security contract.
Mm-hmm.
Token transactions do not need to be fully private.
They don't?
Fully private. So you know the, yeah, you know the, you can know the balance. Or do we want to say fully private? However, if you want to make them fully private, that would be even better.
Right.
Right. So we're saying it's a right. So this is a must, and the other one is a may.
Yeah.
What else do we need?
Well, some number of transactions per second of throughput capability.
Yeah. So we need 1,000 TPS. Right, 1,000 TPS in L2. Right.
Yeah, and these are not just trivial transactions. These are ZK transactions.
L2 as ZKP transactions.
I don't know if there's anything that can do that yet. I just looked up, I just Googled Aztec 2.0 and they claim 300.
Yeah, but again, yeah, you can, but that's fully private. You can, if you
If you relax that, you can do more, yeah.
Yeah, if you relax that, I mean, like you know, with you can do I'm sure you can do 1,000 if you the constraint is what you can write onto L1.
Mm-hmm.
Right, and since this is right, since we're not requiring that, we're requiring an anchoring transaction, right? So they need to think a little bit.
Yeah.
Right.
If you're not requiring privacy, you can do a lot of transactions for sure.
Yeah. I mean, for the you're requiring privacy for the full privacy for the non-token transactions. So they can be, you know, ZKP, but there are significantly less token transactions.
Right.
So you got more flexibility. So they just need to non-token transactions. right?
Mm-hmm.
And then the users need to have the ability to run a non-processing node for visibility.
Mm-hmm.
Anything else? Oh yes, 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 yes. For the smart, or let's talk about the smart contracts.
Yeah, or language support.
Do we want to specify that?
Well, you need some kind of a programming language to be able to implement these tokens, don't you?
Yeah, but you can do that. If you keep them in L2, you just need the investment contract, right? And then you know it's like say tokens should be implemented based on an existing ERC standard, right?
That implies solidity support, doesn't it?
Yes. Oh, if you want to do a
if you're doing
stack
this
that is
in Zinc or some ZK language, then it might be a different standard, mightn't it?
no, if you do it in Zinc, so there's a difference, right? Oh, so okay, so these are L1 smart
Oh,
contracts.
these are the L1s. Okay, gotcha.
Okay, sorry. You know, you are free to utilize an existing general prover language, general prover service language, such as Zinc or
Mm-hmm. Cairo, yeah.
For the L2 business logic.
Mm-hmm.
If you choose to use CKP, right? And
Yeah.
you can use others.
But so I guess a requirement is that there is some kind of programmability on there too.
Yeah. I just leave it like that.
Yeah.
L1 contracts, token contracts should be implemented based on an existing ERC standard.
Sure.
Right. Okay. If CKP, if anchoring with ZKP is utilized, anyone any user should be able to verify a proof.
Mm-hmm.
A proof. Verify a proof of an individual transaction and of the entire proof of and should be verify a proof and a proof of the transaction aggregate. Okay. Right?
Yeah, sounds right.
Right.
Mm-hmm.
So if anchoring does not utilize CKP transaction actions, the anchoring proof needs to be able to be validated by the accessible layer 2 data. In parentheses, non-processing storage, non-processing baseline node.
Yeah.
Make sense?
Yep.
Okay. Oh yes. So the contract architecture needs to be upgradable such that additional contracts can be added without having to remove potentially still useful existing contracts. Smart contract. So smart contract architecture needs to has to be able to prevent DDoS attacks.
How does it do that?
Permissioning, staking through EG, permissioning, staking, limiting of one.
Right. I see what you're saying. Okay. Yeah.
Right.
Yeah. Okay. That makes sense.
Right. So it just says that like you need to do something such that, it's like A, you can, it's not everybody can write to it. B, if they're a permission, but they're doing something bad by writing too often, you restrict it, you restrict that, and you make that expensive by staking where they can be punished.
Okay.
Right. So that's
the smart contract has to have on-chain
Mm-hmm. To upgrade it.
Yeah, for PG for upgrades. Adding node permission or write and read permissions, etc. Or do we need anything else? Well, I think that's a pretty good start.
It's a good start, yeah.
Merd. So what do we have? We have diamond upgrade pattern EIP 2535. We have Matter Labs Zinc framework. Framework and ZK
Porter
Sync. Well, ZK Sync they have, which is open source. It's all open source.
Porter is not.
Porter is not done yet.
Oh, okay.
I don't think. And stack. That is Noir with rollup. With rollup architecture. And that is open source. And then we have Starkware. And that is what's the thing called? Is it Diversify?
Oh, Volition.
2.0.
Oh, StarkX, I think. And StarkX is what they're calling the rollup solution, and then Volition is the flexible on-chain, off-chain data availability.
Yeah. So that is like StarkX, right?
I think so.
Volition. Yeah. Then baseline reference implementation BR11. I think that is as good a start as we can get. What do you think?
It's a pretty good start. I think it would be interesting, just for sake of argument, to think about whether something like Arbitrum would be a possible layer 2.
Well, let's add it here.
Arbitrum SCSC, not their rollup, but they call it sidechains and state channels.
CSC.
SCSC, sidechains and state channels.
Side.
SC,
Oh, side.
SC.
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 SCSC, right?
Yeah. Yeah.
And then yeah. Also Validium, right?
Yeah, I mean, I don't think there is a Validium product outside the three we already talked about. So
Right, that's
ZK
true.
Porter is a form of Validium, and
Yeah,
Vixen
that's
is a
true.
form of
Yeah,
Validium.
yeah, that's true. So let's just leave it at that.
Okay.
I mean, this is a whole month that they have, right?
For what?
For the hackathon.
Oh, okay.
All right, it's not like a weekend. It's not
Yeah.
doable in a weekend, right?
Oh, this is for people to actually try to build.
Yes.
Okay, gotcha. So Arbitrum SCSC is not done yet, so that wouldn't be an option to hack on.
Oh, okay. The other ones are though. There's open source available.
So I wonder if any of this can actually do 1,000 transactions per second of ZK proof verification.
Yeah, then let's do
100.
Let's do 100. Right.
Pretty sure that's doable.
Right, and then let's do it for 10 minutes.
Mm-hmm.
Then the math still works out with the rest.
Mm-hmm.
And then here we have least.
Yeah.
I think the rest is fine. Cool.
Mm-hmm. That's cool.
Awesome. I think we did some yeoman's work here.
I think it was good thinking through this stuff.
Yeah. So what I'm gonna do, and you're happy to do that, I'm gonna take what we have in the mind maps and pour it into requirements here, and scaling evaluation.
Yep. Awesome.
Criteria.
Mm-hmm.
Right. So there's some specific privacy stuff which is beyond that.
Mm-hmm.
Right. And then we can give that as a handout to the hackathonies.
Yeah. Cool.
And the requirements to understand that better. I think that's a good start.
It's good. Yeah, I think it was a useful discussion, and I certainly understand things a lot better now.
Yeah, and it helped me significantly as to think through the hybrid nature and what needs to be where and so forth. So that was really helpful, and seeing that there is not really an issue with like on-chain data as long as you limit the data availability with ZK on-chain proofs to just token transactions.
Yeah. Cool.
Right, and then it actually becomes like those circuits can be much simpler because then it's just like, you just have a mint transaction and you have a transfer and blah blah.
Yeah.
With those.
I was hoping that Tom from Aztec would be in this session. I invited him, and he said he'd participate, but I'm sure they're busy.
Yeah, I mean they're very busy. They're getting pressure to get stuff done.
Yeah.
Cool.
Cool. All right.
Awesome.
That was fun. Thanks.
Excellent. All right.
See you later.
Cheers.